the future of business analytics and impact on business. This unit focuses on future applications and careers in business analytics and future emerging trends and tools, including machine learning and artificial intelligence. The unit begins with a survey of emerging trends in data analytics and particularly the impact of AI. Next, we look at the impact of data analytics in the creation of new products and services and capabilities that add value to the firm. Then we look at career opportunities in business data analytics and the training and tools needed to develop data analytics expertise. Finally, the unit concludes with an overview of resources for further professional development in business data analytics, database programming, machine learning, and artificial intelligence. This topic provides an introduction to the fundamentals of AI-based data analytics and other emerging trends for business decision-making. The topic begins with a survey of several data analytics and business intelligence trends. Next, the concept of decision intelligence is developed, which combines the technical side of quantitative calculations with the human aspects of problem identification and decision-making. That focus on AI-based, database decision-making is continued in the next resource, which looks at the rollout issues of introducing a transformational technology like AI into an existing organization. Finally, a professional data analyst and data analytics trainer looks at the positive and negative impacts AI might have for the job of the data analyst and a forecast of future developments in AI-based analytics. Top 10 Analytics and Business Intelligence Trends for 2025. Over the past decade, business intelligence has exploded. Data has become gigantic, and just like that, we all gained access to the cloud. Spreadsheets finally took a backseat to actionable and insightful data visualizations and interactive business dashboards. The rise of self-service analytics democratized the data product chain. Suddenly, advanced analytics isn't only for analysts. 2024 was a banner year for the business intelligence industry. The trends we presented last year will continue to play out through 2025. However, the BI landscape is evolving, and the future of business intelligence is happening right now with emerging trends to watch. In 2025, BI tools and strategies will become increasingly customized. Businesses of all sizes are no longer asking if they need increased access to business intelligence analytics, but what is the best BI solution for their specific needs? Businesses are no longer wondering if visualizations improve analyses, but what the best way to tell each data story is, especially with the help of modern BI dashboard software. 2025 will be the year of data security and discovery, clean and secure data combined with a simple and powerful presentation. It will also be a year of collaborative BI and AI, where multiple industries will dive into analytics to benefit from the power of data, such as the case of construction business intelligence, which we will discuss in detail later in the post. We are excited to see what this new year will bring. Read on to see our top 10 business intelligence trends for 2025. The top trends in business intelligence. Business intelligence trends for 2025. 1. Construction analytics. As mentioned in the introduction, construction is one of the many industries that has jumped onto the BI train and benefited from advanced analytics. The construction case is interesting because this massive industry has always been recognized as reluctant to change, probably because it is one of the oldest industries in the world, with processes that have been tested repeatedly with positive results, at least until now. However, as the world becomes more digitally driven, the construction industry must keep up with changes. In 2025, we can expect an even bigger adoption of digital construction technologies like AI, digital twins, sensors, and more that will drive the industry forward. Construction analytics can solve many challenges for companies in the building sector, including disparate data sources, outdated reporting, and decentralized teams and systems. These issues lead to costly errors that make projects longer and more expensive. By integrating data management practices and technologies into their workflows, construction companies can benefit from real-time data to make projects more time and cost-efficient from pre-construction planning to completion and handover. This is possible with the support of professional BI software, which offers a centralized location to aggregate data from multiple sources and visualize it in interactive construction reports that anyone can access and understand. Plus, many processes once done manually, like a quantity takeoff or a bill of quantities, can now be automated, saving teams hours of work and significantly reducing the risks of manual errors. That being said, the benefits are not purely operational. From a teamwork perspective, implementing analytics can also be a significant driver of productivity. It is no secret that collaboration and communication in construction projects have always been a challenge. With project stakeholders working from different locations, it is common for communication barriers to bring bigger issues. The proper construction analytics software can easily solve this issue by offering 24/7 access to real-time data in an online environment. This means anyone, regardless of device or location, can access and share the data with others to collaborate and communicate, ensuring everyone is working from a single source of truth. However, adopting new software and practices is not easy. Leaders in the building industry will need to implement well-thought-out construction change management strategies to ensure the process goes smoothly. Involving all employees in the process can boost engagement and make it more effective. 2025 will be an exciting year for the building sector. As the importance of construction project management grows, industry leaders need to invest in technology that will boost teamwork and modernize processes that can no longer be carried out analogically. We look forward to seeing it happen. 2. Artificial intelligence. Artificial intelligence, AI, is the science that aims to make machines execute what is usually done by complex human intelligence. Often seen as the highest foe friend of humans in movies, Skynet in Terminator, the machines of Matrix, or the master control program of Tron, AI is not yet on the verge of destroying us. Despite the legitimate warnings of some reputed scientists and tech entrepreneurs. Artificial intelligence trend. While we work on programs to avoid such inconvenience, AI and machine learning are revolutionizing how we interact with analytics and data management. In addition, increments in security measures must be taken into account. The fact is that it is and will affect our lives, whether we like it or not. It is expected that AI will evolve into a more responsible and scalable technology in the coming year as organizations will require a lot more from AI-based systems. According to Gartner's data and analytics research for 2021, with COVID-19 completely changing the business landscape, historical data will no longer be the primary driver of AI-based technologies. In change, these solutions will need to work with smaller datasets and more adaptive machine learning while also being compliant with new privacy regulations. This concept is known as ethical AI, and it aims to ensure that organizations use AI systems in a way that will not break the law. To this day, many organizations have faced legal issues for illegally collecting user data. The Facebook and Cambridge Analytica scandal is a perfect example of that. In that sense, implementing systems and models to ensure the correct use of AI-related technologies will become even more important in the coming years. In fact, the U.S. government released a blueprint for the AI Bill of Rights, presenting 5 principles that should guide the design, use, and deployment of automated systems to protect the American public in the age of artificial intelligence. In response to this increasing need for AI accountability, Gartner presents AI TRISM as one of the concepts that will help organizations ensure AI model governance, trustworthiness, fairness, reliability, robustness, efficacy, and data protection. This cross-functional framework must be implemented from the earliest stages of system design and involve people from compliance, legal, IT, and analytics for a successful approach. By 2026, businesses that apply this framework to their AI models are expected to be 50% more successful in adoption, business goals, and user acceptance. It can't be denied that AI is still a topic of concern even today. The number of AI-based applications has become so big that many IT professionals don't even know how to use or interpret them. This leaves the door open for breaches and financial losses that can significantly impact companies and customers alike. As a response, terms such as explainable AI, XAI, will be at the center of the conversation during 2025. XAI is an emerging field that aims to apply specific processes and methods to allow humans to understand the results and outputs created by machine learning and AI algorithms. The end goal of this field is to ensure trust and transparency with these systems to give humans control over them. AI-based business analytics. When it comes to analytics, businesses are evolving from static, passive reports of things that have already happened to proactive analytics with dashboards that help them see what is happening at every second and give alerts when something is not how it should be. Solutions such as an AI algorithm based on the most advanced neural networks provide high accuracy in anomaly detection as it learns from historical trends and patterns. That way, any unexpected event will be immediately registered, and the system will notify the user. Another feature that AI has on offer in BI solutions is the upscaled insights capability. It basically fully analyzes your dataset automatically without needing effort on your end. You choose the data source you want to analyze and the column/variable, for instance, revenue, the algorithm should focus on. Then, calculations will be run and come back to you with growth/trends/forecast, value driver, key segments correlations, anomalies, and what-if analysis. That is an incredible time gain as what is usually handled by a data scientist will be performed by a tool, providing business users with access to high-quality insights and a better understanding of their information, even without a strong IT background. Time gain is also present in the form of AI assistants. Tools have started developing AI features that enable users to communicate with the software in plain language. The user types a question or request, and the AI generates the best possible answer. If you are interested in this, keep reading. We will dive into it in more detail later in the post with the natural language processing trend. The demand for real-time online data analysis software is increasing, and the arrival of the IoT, Internet of Things, also brings countless amounts of data, promoting statistical analysis and management at the top of the priority list. However, businesses today want to go further, and adaptive AI might be the answer. As stated by Gartner, adaptive AI systems support a decision-making framework centered around making faster decisions while remaining flexible to adjust as issues arise. These systems are so interesting for companies today because they can learn from behavioral patterns and adjust to real-world changes, making it easier to make fast and improved decisions. In that same realm, generative AI is another technology that has revolutionized the industry in the past few years and will continue to do so in 2025. It basically enables AI systems to generate text, images, audio, and other types of content based on human-generated input. A famous example of generative AI is ChatGPT. In 2023, the tool revolutionized the industry with its ability to generate well-written texts based on a short input. However, as with many AI-related innovations, ChatGPT was quickly scrutinized because it could generate biases, copyright infringement, fake news, and more if not used ethically. From a business perspective, using technologies like adaptive and generative AI has facilitated several processes, including data collection, cleaning, and analysis, which can be automated and tailored to the company's needs. Risk management is another area in which these technologies thrive. Businesses can use generative AI to predict any kind of fraud or attack, as well as generate risk simulations and test strategies in an imaginary scenario. Agentic AI has also emerged as a valuable innovation for AI in business intelligence. It refers to systems and models that can act autonomously to achieve goals without the need for constant human guidance. This is a significant shift from existing rule-based AI models that cannot act independently. Agentic AI is programmed to achieve a goal and act on behalf of a human to achieve that goal. The technology harnesses the creative abilities of generative AI, but differs fundamentally as it does not focus on creating content, but on making decisions. In 2025, Agentic AI is expected to improve human-machine collaboration due to its supercharged reasoning and, most of all, its advanced execution capabilities. Overall, we cannot deny the value of AI and its continued development over the years. A recent study by IBM shows that companies are investing and adopting AI technologies to boost productivity and efficiency, with 63% of executives stating that their AI portfolio will financially impact their organization in the next 2 years. Still, the process is not without challenges, especially when training employees or scaling existing IT infrastructures to support AI with the risk of technical debt. On top of that, regulators and decision-makers must ensure ethical and secure measures are imposed when implementing these systems. Ultimately, it all comes back to security. We will discuss it in more detail in our next trend. 3. Data security. As you have seen with our extensive AI trend, data and information security were hot topics in 2024 and will continue to be so in 2025. The implementation of privacy regulations such as the GDPR, General Data Protection Regulation, in the EU, the CCPA, California Consumer Privacy Act, in the USA, and the LGPD, General Personal Data Protection Law, in Brazil have established the foundation for data security and the management of customers' personal information. Moreover, the European Court of Justice's overturn of the legal framework called Data Privacy Shield hasn't made software companies' lives much easier. The shield enabled them to transfer data from the EU to the USA. Still, recent legal developments have invalidated the process, so companies with headquarters in the US don't have the right to transfer EU data subjects. Actually, a similar situation happened in 2015 when the EU and the USA had no legally valid agreements on this matter for a while. Many US-based software providers argue that they use European servers, and there is no data transfer to the US at all. However, from a legal perspective, even this solution is questionable as, in theory, the U.S. judiciary could force U.S.-based businesses to reveal even data from EU-based servers. In essence, the information that is in the EU needs to stay in the EU. In practice, that means that EU-based businesses that use it in the current situation and US-based software vendors that store any kind of data for them are taking hazards as they operate in a legal gray area. Taking all this into account, businesses have been forced to invest in security to stay compliant with the new regulations and also to protect themselves from cybercrime. In fact, global spending on information security is expected to reach $212 billion by 2025. This is not a surprise to the experts as, during 2020 and the beginning of COVID-19, companies of all sizes were forced to mutate from physical to digital, and, to accelerate the transformation, they relied on online services, leaving a gap for cybercriminals to attack. The advancements in AI have also left the door open to more sophisticated attacks that require even more refined levels of security. According to the 2024 KPMG CEO Outlook Pulse survey, cybersecurity is among the top risks to growth topics for CEOs in the coming years. Even more concerning is that only 54% of CEOs say their organization is prepared for a cyber attack, with 37% of them thinking they are unsure their current security systems can keep up with AI advancements and trends. Gartner predicts that by 2027, 17% of cyber attacks will involve generative AI, leaving organizations in a difficult position. That said, software developers still see this situation as an opportunity and will continue developing robust security solutions to tackle these challenges. Luckily, with the current situation, company boards recognize cybersecurity as an overall business risk more than an IT-related issue. According to Gartner's cybersecurity predictions for 2023 to 2024, by 2026, 70% of boards will include one member with cybersecurity expertise. Amongst the measures organizations are taking in the coming years, we will see an increase in adopting the Zero Trust framework. Zero Trust doesn't describe a specific technology, but an approach in which businesses remove the implicit trust from all computing infrastructure by verifying every stage of digital interaction from devices to users, regardless of location. This means every user who wants to interact with the company's systems needs to be validated and verified. According to Gartner, by 2026, 10% of large enterprises will have a comprehensible, mature, and measurable Zero Trust program in place, compared to the less than 1% that have one today. However, almost half of them might fail as a Zero Trust approach requires full organizational involvement and connection to business goals to succeed. The concern in cybersecurity also presents a challenge for SaaS BI tools as they need to ensure they offer a secure product that clients will trust with their sensitive data. Like any other cloud BI solution, online business intelligence software is also subjected to security risks. Some of them include processing data quickly to provide real-time insights that might be subjected to regulatory compliance, vulnerabilities when moving data from users' systems to the BI tool's cloud, or when the tool provides access to data from multiple devices that may be unsafe and exposed to attacks. To prevent any of this from happening, BI software needs to have a clear focus on security. Cybersecurity mesh architecture is one of the latest trends in business intelligence that helps SaaS BI solutions stay safe. Cybersecurity mesh is a composable and scalable security control that protects digital assets that reside in applications, in the cloud, IT, and others. It seeks to establish a defined security perimeter around a person or a specific point with a more modular approach, enabling users to access data from their smartphones securely. One of Gartner's cybersecurity predictions for 2021 to 2022 stated that by the end of 2024, organizations adopting cybersecurity mesh architecture will reduce the financial impact of security incidents by around 90%. Since data breaches have been regularly in the news, buzzing industries, and average users, the demand for security products and services is understandable. With these security threats increasing, businesses must adopt an organizational approach to protect their data. That is why data governance will remain one of the hottest topics related to security in 2025. This concept refers to a set of processes, policies, and roles that ensure appropriate valuation, creation, consumption, and control of business data at a strategic, tactical, and operational level. It establishes roles and responsibilities regarding who can manipulate the data, in which situation, and with what tools and methods to ensure a secure and efficient data management process. In the past years, tighter regulations such as GDPR have obligated organizations to ensure a secure environment for sensitive data, enhancing the need for stronger governance processes. As we mentioned earlier, companies of all sizes are exposed to attacks and breaches, leaving massive amounts of sensitive information from customers, suppliers, employees, and others exposed to misuse. In that sense, implementing a well-crafted governance plan will help organizations comply with government regulations while setting the perfect environment for using quality data and achieving their goals. The recent implementation of NIS2 on October 18, 2024, is another example of actions that are being taken by regulators to fight cybercrime. This framework aims to enhance the security of network and information systems within the EU by requiring operators of critical infrastructure and essential services to implement appropriate security measures and report any incidents to the relevant authorities. In the coming years, we expect more frameworks like NIS2 to be implemented and companies investing more resources in protecting their data. 4. Synthetic data. Next, in our overview of the top business intelligence trends, we have an interesting and relevant topic that relates to the two trends we already discussed, AI and security, which is synthetic data. Gartner defines synthetic data as artificial data, generated by applying a sampling technique to real-world data or by creating simulation scenarios where models and processes interact to create completely new data not directly taken from the real world. In other words, it is fake data created by generative AI models that mimic real-world data but remove all the personal information from it. To this date, there are two types of synthetic data, partial and full. On one hand, partial synthetic data only replaces a portion of the real data for privacy purposes, for example, contact details about customers. On the other hand, full synthetic data is where new data is generated from scratch, still sampling from existing data but with no actual real-world information. Synthetic data can take various forms, including text, numbers, images, videos, and more. This innovative approach has many benefits. The main one is the capability to generate unlimited amounts of labeled data on demand without having to wait for it to be generated in reality. This massive amount of information is more cost-effective. It can also be used to train AI and ML models, allowing organizations of all sizes and resource levels to capitalize on the power of artificial intelligence and machine learning. In fact, Gartner predicted that by 2030, synthetic data will completely overshadow real data in AI models. Synthetic data can also be used to complement real-world data and test different scenarios even if there is no evidence of that scenario in the real dataset, opening the doors for creativity and innovation that can drive success. Lastly, synthetic data is a great tool to protect sensitive information and stay compliant with privacy laws. For example, a medical researcher can generate synthetic information that shows the same statistically relevant information as real data, but with fake patient names, addresses, etc. That said, while there are many benefits, using artificially manufactured data does not come without challenges. These include quality control issues, a lack of technical expertise to generate and manage the data, and a lack of buy-in from stakeholders. Companies that want to adopt this approach successfully must be willing to invest in training and tools to make it truly effective and beneficial. Even though synthetic data has recently gained visibility, many successful applications are happening across industries. For example, healthcare organizations use it to detect conditions, while financial entities use it to train fraudulent activity detection systems without exposing financial information. 5. DNA sustainability. Moving on with our list of the business intelligence market trends, we have data and analytics, DNA, sustainability. The topic is one of the most important ones we will discuss in this post, as climate change will remain a global concern in the coming years. In recent years, businesses have started exploring sustainability, mostly as a marketing tactic to brand themselves as conscious. As the topic becomes increasingly important, with new regulations forcing organizations to report on their ESG initiatives, decision-makers have realized that sustainability also represents a big way to reduce operating costs and increase overall profitability and efficiency. That is where DNA sustainability comes into the picture. Now that businesses of all sizes and across industries have realized the hidden potential of sustainability, we will start to see many using data and analytics to boost their strategies and maximize their efforts. By tracking important metrics like energy consumption, gas emissions, labor rights, supply chain performance, and others, organizations can extract valuable insights to guide their sustainability journey. In 2025 and beyond, organizations can expect to use DNA sustainability to anticipate changes in demand and adjust their resource purchases and usage to be more financially intelligent. However, other factors will also come into play besides purely resource-related data. Production levels, sales volume, employee headcounts, and even weather data will help paint a more accurate picture to facilitate real-time decision-making. We can also expect to see different tools emerge to help track sustainability data from a past, present, and future perspective, providing a big competitive advantage for companies that manage to adopt it correctly. That being said, ensuring all employees and relevant stakeholders are involved in the process is also necessary. Implementing training instances to engage employees with the process is a good way to start. Linking ESG initiatives to business outcomes is a challenging task. As of today, sustainability analytics is valuable for three main reasons. The first one is to stay compliant with the law. The second one is to track the performance of ESG goals. And the third one is to uncover new opportunities to keep integrating sustainability into operations. Organizational leaders must take charge to ensure all these aspects are covered and supported with the best tools and technologies. At RB Software, we are committed to making the construction industry greener by providing our clients with the best solutions to track their carbon footprint with the help of our professional carbon estimating software, RIB CostX. The platform allows companies in the building industry to estimate the carbon emissions of different material choices thanks to a carbon database. This level of transparency ensures decisions are made with sustainability in mind, mitigating the project's environmental impact. Carbon emissions can also be tracked during the project to extract improvement opportunities to ensure goals are met. It is no secret that sustainability has transitioned from a buzzword to a mandatory practice in the business world. This growing trend will be evident everywhere in 2025 and for many more years to come. 6. Data collaboration. Data and analytics have become a business's most valuable competitive asset. Making informed decisions based on accurate insights can skyrocket success to a whole new level. That being said, analyzing data and extracting insights is not enough, especially considering how accessible it has become to extract and manage valuable business data. To extract the maximum potential from your analytical journey, it is necessary to ensure full organizational adoption through powerful data collaboration and sharing practices, leading us to our next trend. While the importance of data collaboration might seem obvious to some, it presents a challenge for most organizations as, for decades, it was the norm to say, "Don't share data unless." The issue is that in today's context, where most businesses are undergoing digital transformations, not sharing data can be detrimental, as everyone across the company needs to be united to connect analytics to general business goals. In that sense, Gartner advises organizations to switch their mindset to must share data unless. Doing so will enable more robust data and analytic strategies, empowering stakeholders to make agile and informed decisions. Changing the mindset might not be easy, and organizations that don't take it seriously might fail in the process. Gartner suggests establishing trust-based mechanisms to ensure decision-makers trust the data they collect and use to inform their strategies. This way, they will feel confident in using it, sharing it, and resharing it with those who might need it. This can be easily done by tracking data quality metrics and implementing catalogs to compile all the information related to the trustworthiness of the data. When discussing data collaboration, the term self-service BI quickly pops up because those solutions do not require an IT team to access, interpret, and understand all the data. These online BI tools make sharing easier by generating automated reports that can be scheduled at specific times and to specific people. For instance, they enable you to set up business intelligence alerts and share public or embedded dashboards with a flexible level of interactivity. All these possibilities are accessible on all devices, which enhances the decision-making and problem-solving processes critical for today's ever-changing environment. Collaborative information, information enhancement, and collaborative decision-making are the key focus of new BI solutions. However, data collaboration does not only occur around the exchange or updates of some documents. It has to track the progress of meetings, calls, email exchanges, and ideas collection. More recent insights predict that collaborative business intelligence will become more connected to greater systems and larger sets of users. The team's performance will be affected, and the decision-making process will thrive in this new concept. In fact, it is expected that, in 2025, data sharing will move further from just sharing insights and will start from earlier stages. Starting from data exploration and spreading across the entire analytical workflow for a more efficient decision-making process that includes every stakeholder, regardless of location. This last point is especially important when considering the growing security concerns many businesses face today. Implementing a collaborative BI approach enables every stakeholder and data user to be accountable for the decisions he or she makes, ensuring a more secure workflow. What about construction? Data collaboration is another of the BI trends on this list that is highly relevant to the building industry. Construction collaboration has long been considered one of the most challenging areas, as projects are composed of multiple processes, people, and tools, and coordinating all of them takes work. At the same time, effective collaboration can be the key to success in the construction industry. It can keep everyone working from a single source of information, eliminate the risk of rework due to miscommunication, and help projects finish on time and within the expected budget. In 2025 and beyond, construction companies of all sizes need to turn to data as a crucial asset to boost collaboration and communication. Professional construction collaboration software offers the perfect online environment to manage all documentation and information in a single place. Reports, documents, drawings, and more are updated in real time, ensuring everyone is working with the latest data available. An audit trail tracking who changed the data and when ensures a culture of transparency and accountability that improves the efficiency and productivity of construction projects. By implementing a collaborative approach supported by the right tools and processes, developers and average business users are expected to work together under the same analytics umbrella, enabling more united communication and a productive work environment. Let's see how it will be developed in the business intelligence trends topics of 2025. 7. Edge computing. Edge computing is a distributed IT architecture in which user data is processed near where it is generated. This enables faster processing of large volumes of data for better real-time insights. Examples of edge devices include autonomous robots, self-driving cars, intelligent bots, and other IoT devices. The increased analytics capabilities of edge computing solve some common challenges of on-premise data centers, like bandwidth limitations, unexpected network disruptions, and latency issues. This, combined with the growth in the number of devices generating data, particularly IT, and the volumes of data being produced, makes the capabilities of traditional data center infrastructures insufficient, generating a need for an edge approach. Edge computing is already a more established concept in industries like healthcare, factories, and retail, which require near real-time access to secure and reliable data in rapidly changing environments. What makes this out of all BI trends so exciting is its potential to revolutionize other industries and functions, including the construction sector. Construction sites have long struggled to transfer data in a timely and efficient manner. This data is fundamental as it supports effective project management and allows for the expected levels of quality and safety to be met. Edge computing solves this challenge by decentralizing data and bringing it closer to the location where it is generated. This significantly decreases latency and facilitates real-time decision-making. To make this possible, construction sites use IoT devices like sensors and wearables that are installed across the site on materials, machines, and workers. These edge devices generate data about workers' movements or vital signs, equipment usage, environmental conditions, and much more to help construction managers identify potential hazards or improvement opportunities and implement strategies to streamline productivity and ensure safety at all times. Additionally, edge computing reduces cloud storage and bandwidth costs, making it especially beneficial for remote construction sites with limited connectivity. Some common use cases for edge computing in construction include tracking possible safety risks like structural issues, potential gas leaks, unauthorized access to restricted areas, and more, sending instant notifications to mitigate the threat or deal with the problem. Performing predictive maintenance on machines, helping to identify if a machine needs something fixed, and reducing potential downtime and delays. Image classification systems track the progress of various on-site activities in real time and ensure they comply with quality, safety, and sustainability requirements. Real-time monitoring of material and equipment utilization, ensuring each resource is used properly to avoid waste. All in all, edge computing has the potential to revolutionize businesses by helping them extract reliable and faster insights to accelerate their performance. That said, companies need to be careful and invest in edge solutions that allow them to effectively deploy software at a massive scale without unnecessary costs and tasks, can handle a diversity of equipment and devices, and have robust features to manage security concerns, among other things. We look forward to seeing how this trend will develop in 2025. 8. Natural Language Processing (NLP). Natural language processing (NLP) is one of the recent trends in business intelligence that is revolutionizing how companies approach their analytical processes. Considered amongst the most powerful branches of AI, NLP enables computers and machines to understand, learn from, and interpret human language in a spoken or written form, and it can be divided into two subsets: natural language understanding (NLU) and natural language generation (NLG). NLU focuses on understanding the meaning behind text and speech, while NLG focuses on text generation based on specific data input. The growth of this trend has been such in the past years that its $3 billion worldwide market revenue from 2017 is expected to be almost 14 times larger by 2025, reaching $43 billion, according to research by Statista. This is not surprising as language processing applications are already present in our daily lives in the shape of car navigation systems, smart voice assistants like Siri or Alexa, autocomplete text features on our phones, and translation apps, just to name a few. Considering all of that, it is not surprising that businesses have begun to adopt this technology to manage the large amounts of unstructured text data they gather from different sources, such as emails, social media, or surveys. As a response, multiple BI software providers offer their users language insight features. There are two major use cases for which language processing is becoming increasingly popular in the BI industry. Let's look at them in more detail below. BI Data Assistant. Similar to the chatbots we see on multiple websites today, a data assistant is integrated into BI software to answer any analytical questions that a user might have. All you need to do is write a question in human language, and the assistant will provide you with the answer. As the technology matured in the past years, AI-based assistants went from simply showing search results for users to analyze to being able to filter and organize the data to generate analytical insights as an answer. This development has also helped democratize data as non-technical users can simply type a question, and the software will automatically show them an answer without needing complicated calculations or analysis. Sentiment analysis, also known as opinion mining, is the process of analyzing text data to identify its emotional tone. Businesses often use it to analyze comments on social media, emails, blog posts, web chats, and more, and determine whether the tone is negative, positive, or neutral. This allows organizations to extract useful insights regarding product development and brand positioning and understand pain points to improve the customer experience at different touch points. NPL is one of the BI trends we will see developing in multiple areas over the coming years. BI software that exploits this capability with a self-service approach will gain a competitive advantage by allowing users to conduct efficient analysis without the need for any calculations. We will definitely be watching how this technology develops in 2025. 9. Predictive and prescriptive analytics tools. Business analytics of tomorrow is focused on the future and tries to answer the question, what will happen? How can we make it happen? Accordingly, predictive and prescriptive analytics are by far the most discussed business analytics trends among BI professionals, especially since big data is becoming the focus of analytics processes being leveraged by big enterprises and small and medium-sized businesses. Predictive analytics is the practice of extracting information from existing data sets to forecast future probabilities. It's an extension of data mining that refers only to past data. Predictive analytics includes estimated future data and, therefore, always includes the possibility of errors from its definition, although those errors steadily decrease as software that manages large volumes of data today becomes smarter and more efficient. Predictive analytics indicates what might happen in the future with an acceptable level of reliability, including a few alternative scenarios and risk assessments. Applied to business, predictive analytics is used to analyze current data and historical facts to better understand customers, products, and partners, and to identify potential risks and opportunities for a company. Industries harness predictive analytics in different ways. Airlines use it to decide how many tickets to sell at each price for a flight. Hotels try to predict the number of guests they can expect on any given night to adjust prices to maximize occupancy and increase revenue. Marketers determine customer responses or purchases and set up cross-sell opportunities. In contrast, bankers use it to generate a credit score, the number generated by a predictive model that incorporates all the data relevant to a person's creditworthiness. There are plenty of big data examples used in real life, shaping our world, be it in the buying experience or managing customers' data. Predictive analytics must also become accessible for everyone, and in 2025, we will witness even more relevance that will cater to that notion. Self-service analytical possibilities are becoming a criterion for BI vendors and companies alike. Both can profit from it and bring more value to their businesses. The predictive models, in practice, use mathematical models, in other words, forecast engines, to predict future happenings. Users simply select past data points, and the software automatically calculates predictions based on historical and current data, as shown in the example. Predictive Analytics Tool. Among different predictive analytics methods, two are quite popular among data scientists: artificial neural networks, ANN, and autoregressive integrated moving averages, ARIMA. In artificial neural networks, data is processed similarly to that of biological neurons. Technology duplicates biology. Information flows into the mathematical neuron, is processed by it, and the results flow out. This single process becomes a mathematical formula that is repeated multiple times. As in the human brain, the power of neural networks lies in their capability to connect sets of neurons together in layers and create a multidimensional network. The input to the second layer is from the output of the first layer, and the situation repeats itself with every layer. This procedure allows for capturing associations or discovering regularities within a set of patterns with a considerable volume, number of variables, or diversity of the data. ARIMA is a model used for time series analysis that applies data from the past to model the existing data and make predictions about the future. The analysis includes inspection of the autocorrelations, comparing how the current data values depend on past values, especially choosing how many steps into the past should be considered when making predictions. Each part of ARIMA takes care of different sides of model creation. The autoregressive part, AR, tries to estimate the current value by considering the previous one. Any difference between predicted data and real value is used by the moving average, MA, part. We can check if these values are normal, random, and stationary, with constant variation. Any deviations in these points can bring insight into the data series behavior, predict new anomalies, or help to discover underlying patterns not visible by the bare eye. ARIMA techniques are complex, and concluding the results may not be as straightforward as for more basic statistical analysis approaches. However, once the basic principles are grasped, the ARIMA provides a powerful predictive analysis tool. Prescriptive analytics goes a step further into the future. It examines data or content to determine what decisions should be made and which steps are taken to achieve an intended goal. It is characterized by techniques such as graph analysis, simulation, complex event processing, neural networks, recommendation engines, heuristics, and machine learning. Prescriptive analytics tries to see the effect of future decisions and adjust them before they are actually made. This dramatically improves decision-making, as future outcomes are considered in the prediction. Prescriptive analytics can help you optimize scheduling, production, inventory, and supply chain design to deliver what your customers want in the most optimized way. And these are some of the emerging trends in business intelligence that we will hear more about in 2025. 10. Embedded analytics. When data analytics occurs within a user's natural workflow, embedded analytics is the name of the game. Businesses have recognized the potential of embedding various BI components, such as dashboards or reports, into their own application, thus improving their decision-making processes and increasing productivity. Formerly strangled by spreadsheets, companies have realized how utilizing embedded dashboards enables them to provide higher value within their own applications. In fact, the embedded analytics market is expected to reach $182.7 billion by 2033, exhibiting a growth rate, CAGR, of 12.82% during 2025 to 2033. This is definitely one of the business analytics trends we will hear even more about in 2025. Whether you need to create a sales report or send multiple dashboards to clients, embedded analytics is becoming a standard in business operations. In 2025, we will see even more companies adopting it. Departments and company owners seek professional solutions to present their data without building their own software. By simply white labeling the chosen application, organizations can achieve a polished presentation and reporting they can offer consumers. More than just embedding a dashboard or BI features in an application, embedding analytics allows for collaboration by keeping every single stakeholder involved. By allowing clients and employees to manipulate the data in a well-known environment, you facilitate the extraction of insights from every area of your business. This makes it one of the fastest-growing business intelligence trends on this list. Business Wire recently published a report called Global Embedded Analytics Market, 2021 to 2026, Growth, Trends, COVID-19 Impact, and Forecasts, in which they mention that organizations are deploying embedded analytics solutions to realize significant gains in revenue growth, marketplace expansion, and competitive advantage. They also add that embedding analytics will grow significantly in the healthcare industry in the coming years. Considering the massive amounts of data that hospitals collect, which got even bigger with COVID-19 and telemedicine interactions, healthcare businesses switch from paying for service volume towards service value. By using powerful healthcare analytics software that can be embedded, hospital managers can extract valuable insights that will help them optimize processes from a clinical, operational, and financial point of view. This is one of the trends in business analytics that can be implemented immediately since many vendors already offer this opportunity and ensure that the application works seamlessly and without much complexity. Become data-driven in 2025. In this article, we've summed up what the near future of business intelligence looks like for us. Here are the top 10 analytics and business intelligence trends we will talk about in 2025. Artificial intelligence, data security, synthetic data, DNA sustainability, data collaboration, continuous intelligence, edge computing, natural language processing, predictive and prescriptive analytics tools, embedded analytics. Being data-driven is no longer an ideal. It is an expectation in the modern business world. 2025 will be an exciting year of looking past all the hype and moving towards extracting the maximum value from state-of-the-art online business intelligence software. The future of data, how decision intelligence is revolutionizing data. A guide to understanding the what, why, and how of decision intelligence. In the past few years, technology and AI have evolved more than ever. As I read about the new concepts in tech and learn new skills and techniques each day, I feel in a state of limbo. There is so much content to consume and yet very little content that I could create. In the rapidly expanding technological world of today, AI is taking over as it gets increasingly integrated into the various aspects of our lives. With the growing concerns around AI usage, it is quintessential to have tools and applications that build trust in artificial intelligence, support business automation, and drive faster, more accurate decision-making. That is exactly where decision intelligence, DI, comes into the picture. In this blog, I want to introduce the readers to the concept of decision intelligence, a very nuanced and rapidly growing concept. This will be your guide to knowing the what, why, and how of decision intelligence. Introduction to decision intelligence. A good decision is often defined by its outcome. But how do you ensure that you're making the best choice? This is where decision intelligence, DI, becomes important for organizations making focused, contextual, and personalized decisions. Decision intelligence is an interdisciplinary field that uses AI to enhance all aspects of decision-making across all areas of a business. It blends concepts of data science, statistics, machine learning, AI, analytics, with behavioral sciences, psychology, neuroscience, economics, and managerial sciences to understand how decisions are made and how outcomes are measured. What is the difference between decision intelligence and artificial intelligence? Artificial intelligence is about creating systems or machines that can do tasks that usually need human intelligence, like learning from experience, recognizing patterns, solving problems, understanding language, and making decisions. Decision intelligence, DI, can be considered a subset where it uses AI to build a reliable data foundation by collecting, organizing, and connecting data and then applying AI and analytics to turn that data into useful insights for better decision-making. In short, while AI provides the technology to mimic human intelligence, DI focuses on applying that technology to improve how decisions are made. How to practice decision intelligence. You can use any of your machine learning models, like regression models, classification models, time series forecasting models, clustering algorithms, or reinforcement learning for implementing decision intelligence. These machine learning will help identify patterns in the data and make predictions based on those patterns. But decision intelligence will take that information one step further by incorporating it into a broader framework that can actively guide the decision-making process by considering the predictions and the potential outcomes and consequences of different choices. Here's how you can start using DI in your decision-making process. Pick a real-world problem. Choose a problem statement that is complex, unpredictable, or full of uncertainty. List out possible outcomes. List all the possible outcomes. Brainstorm actions. List all the steps and actions that could lead to those outcomes. Identify key factors. Consider what data points might influence how your actions impact the outcomes. Connect the dots. Analyze the relationship between your actions and possible results. Implement your decision model. Put your plan into action. Review and refine. No decision process is perfect. Keep tweaking and improving it over time. Decision intelligence creates value through increased revenue, cost reduction, improved efficiency, and risk mitigation, and that makes decision intelligence important for organizations. Where to use decision intelligence? One of the most important factors for a successful implementation of decision intelligence is selecting the right use case with high business value and feasibility. Decision intelligence platforms work at the confluence of data science, predictive analytics, and machine learning concepts that can empower these teams by providing them a comprehensive pool of all relevant data sources to run custom-made data models per an organization's unique data sources, investigation types, and use cases. Decision intelligence finds its use cases in many industries. For example, in retail, it helps with setting product prices and managing inventory. In healthcare, it can create personalized treatment plans. In finance, it can be used to assess credit risk and detect fraud. In manufacturing, it can help improve production processes, and in transportation, it can help plan efficient routes and maintain vehicles. Many teams try to start an applied AI project by diving into algorithms and data before figuring out desired outputs and objectives. Unfortunately, that's like raising a puppy in a New York City apartment for a few years, then being surprised that it can't herd sheep for you. You can't expect to get anything useful by asking wizards to sprinkle machine learning magic on your business without some effort from you first. Instead, the first step is for the owner. That's you. To form a clear vision of what you want from your dog or ML/AI system and how you'll know you've trained it successfully. My previous article discussed the why. Now it's time to dive into how to do this first step for ML/AI with all its gory little sub-steps. This reference guide is densely packed and long, so feel free to stick to large fonts and headings for a 2-minute crash course or head straight to the summary checklist version. Here's the table of contents. Here's a detailed summary of the attached Forrester Consulting report commissioned by Google in July 2020, titled The Future of Analytics. Firms seek advanced tools to improve customer experiences and marketing outcomes. Executive summary. Many brands have web and app experiences, but lack unified data across the customer journey. Existing analytics tools are inconsistent, siloed, and provide incomplete views of customer behavior. Firms want cross-platform, user-first, flexible, and privacy-safe analytics tools. Organizations with advanced tools gain clearer insights into buyer needs, improve customer experiences, and increase retention. Survey of 750 marketing decision makers, firms with greater than 500 employees, shows progress, but significant gaps remain. Key findings. Cross-platform analytics is rare. Only 43% of firms have unified web plus app analytics. Privacy is a top priority. Decision makers value platforms that unify user behavior in a privacy-safe way. Customer experience is the main benefit. Firms use analytics primarily to improve satisfaction and retention, not just acquisition. Advanced capabilities needed. Firms want sophisticated user management, advanced features, and strong support. Firms sharpen analytics focus. Analytics is a top marketing priority. 63% of marketers rank improving data/analytics in their top 5 priorities. Benefits realized: improved customer experience, 43%, better campaign outcomes, 42%, and better understanding of the customer journey, 39%. Advanced needs: firms invest in analytics tools for exclusive features, advanced user management, and fresher data. Limitations and challenges. Data management struggles. 54% cite inability to manage data volume. Outdated tagging and freshness issues are common. Siloed data. 57% struggle with disconnected data across teams/platforms. Tool limitations. 56% say current tools don't surface insights easily. 52% say tools lack customization. Cross-platform gap. 84% see cross-platform analytics as critical, but only 44% are effective at it. Machine learning gap. 81% say ML is critical, but only 44% find their tools effective at ML insights. Next-generation analytics needs. Predictive analytics. Firms want flexible, customizable predictive tools integrated with existing stacks. Privacy-safe solutions. Half of respondents prioritize privacy-safe cross-platform analytics. Better data management. 70% plan to adopt cloud/data warehouse solutions in the next 12 months. Cross-platform growth. 66% plan to expand cross-platform capabilities. 64% plan to strengthen privacy/data controls. Benefits of cross-platform tools. Users report 1.3x more complete and accurate insights, leading to better experiences and campaigns. Key recommendations. Invest in cross-platform analytics tools to unify customer journeys across web and mobile. Adopt AI or ML capabilities to generate faster, deeper insights and automate decision-making. Take a privacy-first mindset to build trust and meet evolving regulations. Focus on critical customer journeys once cross-platform analytics is in place, using insights to remediate gaps and frustrations. Methodology. Online survey of 750 decision-makers, analytics, media, marketing insights. Respondents from multiple regions: US, UK, France, Germany, Japan, Australia. Company sizes: 500, 20, 000 plus employees. Roles: 34% C-level, 30% directors, 25% managers. Industries: retail, manufacturing, technology, financial services, healthcare, telecom, etc. Overall takeaway. The report emphasizes that future-ready analytics platforms must be cross-platform, privacy-safe, AI or ML-enabled, and customizable. Firms that invest in these capabilities will deliver better customer experiences, improve retention, and achieve stronger marketing outcomes. This topic introduced the fundamentals of AI-based data analytics and other emerging trends for business decision-making. The topic begins with a survey of several data analytics and business intelligence trends. Next, the concept of decision intelligence was developed, which combines the technical side of quantitative calculations with the human aspects of problem identification and decision-making. That focus on AI-based, database decision-making was continued in the next resource, which looks at the rollout issues of introducing a transformational technology like AI into an existing organization. Finally, a professional data analyst and data analytics trainer looked at the positive and negative impacts AI might have for the job of the data analyst and a forecast of future developments in AI-based analytics. This topic delves further into the impact of data analytics throughout the organization and the requirement to demonstrate value added from the investment in data analytics capabilities. The topic begins with an extensive discussion of the types of data value obtained from data analytics implementation in various functional areas of the traditional business value chain. Next, we examine 10 real-world used cases in a variety of industries. The topic concludes with an examination of the benefits of business intelligence applications in small businesses. Data science case studies in retail. 1. Walmart. With humble beginnings as a simple discount retailer, today, Walmart operates in 10,500 stores and clubs in 24 countries and e-commerce websites, employing around 2.2 million people around the globe. For the fiscal year ended January 31, 2021, Walmart's total revenue was $559 billion, showing a growth of $35 billion with the expansion of the e-commerce sector. Walmart is a data-driven company that works on the principle of everyday low cost for its consumers. To achieve this goal, they heavily depend on the advances of their data science and analytics department for research and development, also known as Walmart Labs. Walmart is home to the world's largest private cloud, which can manage 2.5 petabytes of data every hour. To analyze this humongous amount of data, Walmart has created Data Cafe, a state-of-the-art analytics hub located within its Bentonville, Arkansas headquarters. The Walmart Labs team heavily invests in building and managing technologies like cloud, data, DevOps, infrastructure, and security. Walmart is experiencing massive digital growth as the world's largest retailer. Walmart has been leveraging big data and advances in data science to build solutions to enhance, optimize, and customize the shopping experience and serve their customers in a better way. At Walmart Labs, data scientists are focused on creating data-driven solutions that power the efficiency and effectiveness of complex supply chain management processes. Here are some of the applications of data science at Walmart. 1. Personalized customer shopping experience. Walmart analyzes customer preferences and shopping patterns to optimize the stocking and displaying of merchandise in their stores. Analysis of big data also helps them understand new item sales, make decisions on discontinuing products, and the performance of brands. 2. Order sourcing and on-time delivery promise. Millions of customers view items on Walmart.com, and Walmart provides each customer a real-time estimated delivery date for the items purchased. Walmart runs a back-end algorithm that estimates this based on the distance between the customer and the fulfillment center, inventory levels, and shipping methods available. The supply chain management system determines the optimum fulfillment center based on distance and inventory levels for every order. It also has to decide on T. 3. Packing optimization. Also known as box recommendation, is a daily occurrence in the shipping of items in retail and e-commerce business. When items of an order or multiple orders for the same customer are ready for packing, Walmart has developed a recommender system that picks the best-sized box, which holds all the ordered items with the least in-box space wastage within a fixed amount of time. This bin packing problem is a classic NP-hard problem familiar to data scientists. Whenever items of an order or multiple orders placed by the same customer are picked from the shelf and are ready for packing, the box recommendation system determines the best-sized box to hold all the ordered items with a minimum of in-box space wasted. This problem is known as the bin packing problem, another classic NP-hard problem familiar to data scientists. Here is a link to a sales prediction data science case study to help you understand the applications of data science in the real world. Walmart Sales Forecasting Project uses historical sales data for 45 Walmart stores located in different regions. Each store contains many departments, and you must build a model to project the sales for each department in each store. This data science case study aims to create a predictive model to predict the sales of each product. You can also try your hands-on inventory demand forecasting data science project to develop a machine learning model to forecast inventory demand accurately based on historical sales data. Get closer to your dream of becoming a data scientist with 70+ solved end-to-end ML projects. 2. Amazon. Amazon is an American multinational technology-based company based in Seattle, USA. It started as an online bookseller, but today it focuses on e-commerce, cloud computing, digital streaming, and artificial intelligence. It hosts an estimate of 1 billion gigabytes of data across more than 1,400,000 servers. Through its constant innovation in data science and big data, Amazon is always ahead in understanding its customers. Here are a few data analytics case study examples at Amazon. 1. Recommendation systems. Data science models help Amazon understand the customer's needs and recommend them to them before the customer searches for a product. This model uses collaborative filtering. Amazon uses 152 million customer purchases data to help users to decide on products to be purchased. The company generates 35% of its annual sales using the recommendation-based systems (RBS) method. Here is a recommender system project to help you build a recommendation system using collaborative filtering. 2. Retail price optimization. Amazon product prices are optimized based on a predictive model that determines the best price so that the users do not refuse to buy it based on price. The model carefully determines the optimal prices considering the customer's likelihood of purchasing the product and thinks the price will affect the customer's future buying patterns. Price for a product is determined according to your activity on the website, competitors' pricing, product availability, item preferences, order history, expected profit margin, and other factors. Check out this retail price optimization project to build a dynamic pricing model. 3. Fraud detection. Being a significant e-commerce business, Amazon remains at high risk of retail fraud. As a preemptive measure, the company collects historical and real-time data for every order. It uses machine learning algorithms to find transactions with a higher probability of being fraudulent. This proactive measure has helped the company restrict clients with an excessive number of returns of products. You can look at this credit card fraud detection project to implement a fraud detection model to classify fraudulent credit card transactions. 3. Netflix. Netflix started as a DVD rental service in 1997 and then has expanded into the streaming business. Headquartered in Los Gatos, California, Netflix is the largest content streaming company in the world. Currently, Netflix has over 208 million paid subscribers worldwide, and with thousands of smart devices which are presently streaming supported, Netflix has around 3 billion hours watched every month. The secret to this massive growth and popularity of Netflix is its advanced use of data analytics and recommendation systems to provide personalized and relevant content recommendations to its users. The data is collected over 100 billion events every day. Here are a few examples of data analysis case studies applied at Netflix. 1. Personalized recommendation system. Netflix uses over 1,300 recommendation clusters based on consumer viewing preferences to provide a personalized experience. Some of the data that Netflix collects from its users include viewing time, platform searches for keywords, metadata related to content abandonment, such as content pause time, rewind, rewatched. Using this data, Netflix can predict what a viewer is likely to watch and give a personalized watch list to a user. Some of the algorithms used by the Netflix recommendation system are personalized video ranking, trending now ranker, and the continue watching now ranker. 2. Content development using data analytics. Netflix uses data science to analyze the behavior and patterns of its user to recognize themes and categories that the masses prefer to watch. This data is used to produce shows like The Umbrella Academy and Orange is the New Black and The Queen's Gambit. These shows seem like a huge risk, but are significantly based on data analytics using parameters, which assured Netflix that they would succeed with its audience. Data analytics is helping Netflix come up with content that their viewers want to watch even before they know they want to watch it. 3. Marketing analytics for campaigns. Netflix uses data analytics to find the right time to launch shows and ad campaigns to have maximum impact on the target audience. Marketing analytics helps come up with different trailers and thumbnails for other groups of viewers. For example, the House of Cards Season 5 trailer with a giant American flag was launched during the American presidential elections, as it would resonate well with the audience. Here is a customer segmentation project using association rule mining to understand the primary grouping of customers based on various parameters. Get free access to machine learning example codes for data cleaning, data munging, and data visualization. 4. Spotify. In a world where purchasing music is a thing of the past and streaming music is a current trend, Spotify has emerged as one of the most popular streaming platforms. With 320 million monthly users, around 4 billion playlists, and approximately 2 million podcasts, Spotify leads the pack among well-known streaming platforms like Apple Music, Wynk, Songza, Amazon Music, etc. The success of Spotify has mainly depended on data analytics. By analyzing massive volumes of listener data, Spotify provides real-time and personalized services to its listeners. Most of Spotify's revenue comes from paid premium subscriptions. Here are some of the examples of case study on data analytics used by Spotify to provide enhanced services to its listeners. 1. Personalization of content using recommendation systems. Spotify uses BART or Bayesian additive regression trees to generate music recommendations to its listeners in real time. BART ignores any song a user listens to for less than 30 seconds. The model is retrained every day to provide updated recommendations. A new patent granted to Spotify for an AI application is used to identify a user's musical tastes based on audio signals, gender, age, accent to make better music recommendations. Spotify creates daily playlists for its listeners based on the taste profiles called daily mixes, which have songs the user has added to their playlists or created by the artists that the user has included in their playlists. It also includes new artists and songs that the user might be unfamiliar with but might improve the playlist. Similar to it is the weekly release radar playlists that have newly released artist songs that the listener follows or has liked before. 2. Target marketing through customer segmentation. With user data for enhancing personalized song recommendations, Spotify uses this massive dataset for targeted ad campaigns and personalized service recommendations for its users. Spotify uses ML models to analyze the listener's behavior and group them based on music preferences, age, gender, ethnicity, etc. These insights help them create ad campaigns for a specific target audience. One of their well-known ad campaigns was the meme-inspired ads for potential target customers, which was a huge success globally. 3. CNNs for classification of songs and audio tracks. Spotify builds audio models to evaluate the songs and tracks, which helps develop better playlists and recommendations for its users. These allow Spotify to filter new tracks based on their lyrics and rhythms and recommend them to users like similar tracks, collaborative filtering. Spotify also uses NLP, natural language processing, to scan articles and blogs to analyze the words used to describe songs and artists. These analytical insights can help group and identify similar artists and songs and leverage them to build playlists. Here is a music recommender system project for you to start learning. We have listed another music recommendations dataset for you to use for your projects. Dataset 1. You can use this dataset of Spotify metadata to classify songs based on artists, mood, liveliness. Plot histograms. heat maps to get a better understanding of the dataset. Use classification algorithms like logistic regression, SVM, and principal component analysis to generate valuable insights from the dataset. Data analytics case study examples in travel industry. Below you will find case studies for data analytics in the travel and tourism industry. 5. Airbnb. Airbnb was born in 2007 in San Francisco and has since grown to 4 million hosts and 5.6 million listings worldwide who have welcomed more than 1 billion guest arrivals in almost every country across the globe. Airbnb is active in every country on the planet except for Iran, Sudan, Syria, and North Korea. That is around 97.95% of the world. Using data as a voice of their customers, Airbnb uses the large volume of customer reviews, host inputs to understand trends across communities, rate user experiences, and uses these analytics to make informed decisions to build a better business model. The data scientists at Airbnb are developing exciting new solutions to boost the business and find the best mapping for its customers and hosts. Airbnb data servers serve approximately 10 million requests a day and process around 1 million search queries. Data is the voice of customers at Airbnb and offers personalized services by creating a perfect match between the guests and hosts for a supreme customer experience. 1. Recommendation systems and search ranking algorithms. Airbnb helps people find local experiences in a place with the help of search algorithms that make searches and listings precise. Airbnb uses a listing quality score to find homes based on the proximity to the search location and uses previous guest reviews. Airbnb uses deep neural networks to build models that take the guests' earlier stays into account and area information to find a perfect match. The search algorithms are optimized based on guest and host preferences, rankings, pricing, and availability to understand users' needs and provide the best match possible. 2. Natural language processing for review analysis. Airbnb characterizes data as the voice of its customers. The customer and host reviews give a direct insight into the experience. The star ratings alone cannot be an excellent way to understand it quantitatively. Hence, Airbnb uses natural language processing to understand reviews and the sentiments behind them. The NLP models are developed using convolutional neural networks. Practice this sentiment analysis project for analyzing product reviews to understand the basic concepts of natural language processing. 3. Smart pricing using predictive analytics. The Airbnb hosts community uses the service as a supplementary income. The vacation homes and guest houses rented to customers provide for rising local community earnings as Airbnb guests stay 2.4 times longer and spend approximately 2.3 times the money compared to a hotel guest. The profits are a significant positive impact on the local neighborhood community. Airbnb uses predictive analytics to predict the prices of the listings and help the hosts set a competitive and optimal price. The overall profitability of the Airbnb host depends on factors like the time invested by the host and responsiveness to changing demands for different seasons. The factors that impact the real-time smart pricing are the location of the listing, proximity to transport options, season, and amenities available in the neighborhood of the listing. Here is a price prediction project to help you understand the concept of predictive analysis, which is widely common in case studies for data analytics. 6. Uber. Uber is the biggest global taxi service provider. As of December 2018, Uber has 91 million monthly active consumers and 3.8 million drivers. Uber completes 14 million trips each day. Uber uses data analytics and big data-driven technologies to optimize their business processes and provide enhanced customer service. The data science team at Uber has been exploring futuristic technologies to provide better service constantly. Machine learning and data analytics help Uber make data-driven decisions that enable benefits like ride-sharing, dynamic price surges, better customer support, and demand forecasting. Here are some of the real-world data science projects used by Uber. 1. Dynamic pricing for price surges and demand forecasting. Uber prices change at peak hours based on demand. Uber uses surge pricing to encourage more cab drivers to sign up with the company to meet the demand from the passengers. When the prices increase, the driver and the passenger are both informed about the surge in price. Uber uses a predictive model for price surging called the GeoSurge patented. It is based on the demand for the ride and the location. 2. One-click chat. Uber has developed a machine learning and natural language processing solution called One-Click Chat, or OCC, for coordination between drivers and users. This feature anticipates responses for commonly asked questions, making it easy for the drivers to respond to customer messages. Drivers can reply with the click of just one button. One-Click Chat is developed on Uber's machine learning platform Michelangelo to perform NLP on rider chat messages and generate appropriate responses to them. 3. Customer retention. Failure to meet the customer demand for cabs could lead to users opting for other services. Uber uses machine learning models to bridge this demand-supply gap. By using prediction models to predict the demand in any location, Uber retains its customers. Uber also uses a tier-based reward system, which segments customers into different levels based on usage. The higher level the user achieves, the better are the perks. Uber also provides personalized destination suggestions based on the history of the user and their frequently traveled destinations. You can take a look at this Python chatbot project and build a simple chatbot application to understand better the techniques used for natural language processing. You can also practice the working of a demand forecasting model with this project using time series analysis. You can look at this project, which uses time series forecasting and clustering on a dataset containing geospatial data for forecasting. Customer demand for Ola rides. Explore more data science and machine learning projects for practice. Fast-track your career transition with Project Pro. Case studies for data analytics in social media. 7. LinkedIn. LinkedIn is the largest professional social networking site with nearly 800 million members in more than 200 countries worldwide. Almost 40% of the users access LinkedIn daily, clocking around 1 billion interactions per month. The data science team at LinkedIn works with this massive pool of data to generate insights to build strategies, apply algorithms and statistical inferences to optimize engineering solutions, and help the company achieve its goals. Here are some of the real-world data science projects at LinkedIn. 1. LinkedIn Recruiter implements search algorithms and recommendation systems. LinkedIn Recruiter helps recruiters build and manage a talent pool to optimize the chances of hiring candidates successfully. This sophisticated product works on search and recommendation engines. The LinkedIn Recruiter handles complex queries and filters on a constantly growing large dataset. The results delivered have to be relevant and specific. The initial search model was based on linear regression, but was eventually upgraded to gradient-boosted decision trees to include nonlinear correlations in the dataset. In addition to these models, the LinkedIn Recruiter also uses the generalized linear mix model to improve the results of prediction problems to give personalized results. 2. Recommendation systems personalized for newsfeed. The LinkedIn newsfeed is the heart and soul of the professional community. A member's newsfeed is a place to discover conversations among connections, career news, posts, suggestions, photos, and videos. Every time a member visits LinkedIn, machine learning algorithms identify the best exchanges to be displayed on the feed by sorting through posts and ranking the most relevant results on top. The algorithms help LinkedIn understand member preferences and help provide personalized news feeds. The algorithms used include logistic regression, gradient-boosted decision trees, and neural networks for recommendation systems. 3. CNNs to detect inappropriate content. To provide a professional space where people can trust and express themselves professionally in a safe community has been a critical goal at LinkedIn. LinkedIn has heavily invested in building solutions to detect fake accounts and abusive behavior on their platform. Any form of spam, harassment, inappropriate content is immediately flagged and taken down. These can range from profanity to advertisements for illegal services. LinkedIn uses a convolutional neural networks-based machine learning model. This classifier trains on a training dataset containing accounts labeled as either inappropriate or appropriate. The inappropriate list consists of accounts having content from blocklisted phrases or words and a small portion of manually reviewed accounts reported by the user community. Here is a text classification project to help you understand NLP basics for text classification. You can find a news recommendation system dataset to help you build a personalized news recommender system. You can also use this dataset to build a classifier using logistic regression, naive Bayes, or neural networks to classify toxic comments. Real-world data science projects in healthcare. 8. Pfizer. Pfizer is a multinational pharmaceutical company headquartered in New York, USA. One of the largest pharmaceutical companies globally known for developing a wide range of medicines and vaccines in disciplines like immunology, oncology, cardiology, and neurology. Pfizer became a household name in 2010 when it was the first to have a COVID-19 vaccine with FDA. In early November 2021, the CDC has approved the Pfizer vaccine for kids aged 5 to 11. Pfizer has been using machine learning and artificial intelligence to develop drugs and streamline trials, which played a massive role in developing and deploying the COVID-19 vaccine. Here are a few data analytics case studies by Pfizer. 1. Identifying patients for clinical trials. Artificial intelligence and machine learning are used to streamline and optimize clinical trials to increase their efficiency. Natural language processing and exploratory data analysis of patient records can help identify suitable patients for clinical trials. These can help identify patients with distinct symptoms. These can help examine interactions of potential trial members' specific biomarkers, predict drug interactions and side effects, which can help avoid complications. Pfizer's AI implementation helped rapidly identify signals within the noise of millions of data points across their 44,000 candidate COVID-19 clinical trial. 2. Supply chain and manufacturing. Data science and machine learning techniques help pharmaceutical companies better forecast demand for vaccines and drugs and distribute them efficiently. Machine learning models can help identify efficient supply systems by automating and optimizing the production steps. These will help supply drugs customized to small pools of patients in specific gene pools. Pfizer uses machine learning to predict the maintenance cost of equipment used. Predictive maintenance using AI is the next big step for pharmaceutical companies to reduce costs. 3. Drug development. Computer simulations of proteins and tests of their interactions and yield analysis help researchers develop and test drugs more efficiently. In 2016, Watson Health and Pfizer announced a collaboration to utilize IBM Watson for drug discovery to help accelerate Pfizer's research in immuno-oncology, an approach to cancer treatment that uses the body's immune system to help fight cancer. Deep learning models have been used recently for bioactivity and synthesis prediction for drugs and vaccines in addition to molecular design. Deep learning has been a revolutionary technique for drug discovery as it factors everything from new applications of medications to possible toxic reactions, which can save millions in drug trials. You can create a machine learning model to predict molecular activity to help design medicine using this dataset. You may build a CNN or a deep neural network for this data analyst case study project. Access data science and machine learning project code examples. Data analytics case studies in oil and gas. 9. Shell Data Analyst Case Study Project. Shell is a global group of energy and petrochemical companies with over 80,000 employees in around 70 countries. Shell uses advanced technologies and innovations to help build a sustainable energy future. Shell is going through a significant transition as the world needs more and cleaner energy solutions to be a clean energy company by 2050. It requires substantial changes in the way in which energy is used. Digital technologies, including AI and machine learning, play an essential role in this transformation. These include efficient exploration and energy production, more reliable manufacturing, more nimble trading, and a personalized customer experience. Using AI in various phases of the organization will help achieve this goal and stay competitive in the market. Here are a few data analytics case studies in the petrochemical industry. 1. Precision drilling. Shell is involved in the processing mining oil and gas supply, ranging from mining hydrocarbons to refining the fuel to retailing them to customers. Recently, Shell has included reinforcement learning to control the drilling equipment used in mining. Reinforcement learning works on a reward-based system based on the outcome of the AI model. The algorithm is designed to guide the drills as they move through the surface, based on the historical data from drilling records. It includes information such as the size of drill bits, temperatures, pressures, and knowledge of the seismic activity. This model helps the human operator understand the environment better, leading to better and faster results with minor damage to machinery used. 2. Efficient charging terminals. Due to climate changes, governments have encouraged people to switch to electric vehicles to reduce carbon dioxide emissions. However, the lack of public charging terminals has deterred people from switching to electric cars. Shell uses AI to monitor and predict the demand for terminals to provide efficient supply. Multiple vehicles charging from a single terminal may create a considerable grid load, and predictions on demand can help make this process more efficient. 3. Monitoring service and charging stations. Another Shell initiative trialed in Thailand and Singapore is the use of computer vision cameras, which can think and understand to watch out for potentially hazardous activities like lighting cigarettes in the vicinity of the pumps while refueling. The model is built to process the content of the captured images and label and classify it. The algorithm can then alert the staff and hence reduce the risk of fires. You can further train the model to detect rash driving or thefts in the future. Here is a project to help you understand multi-class image classification. You can use the hourly energy consumption dataset to build an energy consumption prediction model. You can use time series with XGBoost to develop your model. 10. Zomato case study on data analytics. Zomato was founded in 2010 and is currently one of the most well-known food tech companies. Zomato offers services like restaurant discovery, home delivery, online table reservation, online payments for dining, etc. Zomato partners with restaurants to provide tools to acquire more customers while also providing delivery services and easy procurement of ingredients and kitchen supplies. Currently, Zomato has over 2 lakh restaurant partners and around 1 lakh delivery partners. Zomato has closed over 10 crore delivery orders as of date. Zomato uses ML and AI to boost their business growth, with a massive amount of data collected over the years from food orders and user consumption patterns. Here are a few examples of data analyst case study project developed by the data scientists at Zomato. 1. Personalized recommendation system for homepage. Zomato uses data analytics to create personalized homepages for its users. Zomato uses data science to provide order personalization, like giving recommendations to the customers for specific cuisines, locations, prices, brands, etc. Restaurant recommendations are made based on a customer's past purchases, browsing history, and what other similar customers in the vicinity are ordering. This personalized recommendation system has led to a 15% improvement in order conversions and click-through rates for Zomato. You can use the restaurant recommendation dataset to build a restaurant recommendation system to predict what restaurants customers are most likely to order from, given the customer location, restaurant information, and customer order history. 2. Analyzing customer sentiment. Zomato uses natural language processing and machine learning to understand customer sentiments using social media posts and customer reviews. These help the company gauge the inclination of its customer base towards the brand. Deep learning models analyze the sentiments of various brand mentions on social networking sites like Twitter, Instagram, LinkedIn, and Facebook. These analytics give insights to the company, which helps build the brand and understand the target audience. 3. Predicting food preparation time, FPT. Food delivery time is an essential variable in the estimated delivery time of the order placed by the customer using Zomato. The food preparation time depends on numerous factors like the number of dishes ordered, time of the day, footfall in the restaurant, day of the week, etc. Accurate prediction of the food preparation time can help make a better prediction of the estimated delivery time, which will help delivery partners less likely to breach it. Zomato uses a bidirectional LSTM-based deep learning model that considers all these features and provides food preparation time for each order in real time. Data scientists are companies' secret weapons when analyzing customer sentiments and behavior and leveraging it to drive conversion, loyalty, and profits. These 10 data science case studies projects with examples and solutions show you how various organizations use data science technologies to succeed and be at the top of their field. To summarize, data science has not only accelerated the performance of companies, but has also made it possible to manage and sustain their performance with ease. How data analytics impacts small businesses in 2025. SMBs was just beginning. As a pioneer in the SaaS industry, Salesforce provided businesses with a platform that constantly monitored and recorded employee actions and tracked KPIs. The vast amount of data it captured and its robust reporting capabilities allowed business owners to analyze performance metrics for individuals, teams, and companies. Today, nearly all business applications, including CRMs, accounting software, and human resource information systems, HRS, record real-time actions and changes. These platforms generate massive volumes of data that seamlessly integrate with analytics tools. This integration provides SMBs with detailed insights to inform cost reductions, improve profitability, and identify inefficiencies. We'll look at current trends affecting SMB data analytics and share how businesses use data analytics today. 5 data analytics trends impacting small businesses in 2025. To remain competitive, businesses must use data to better understand their customers and find ways to work more efficiently. Here are 5 key analytic trends impacting small businesses. 1. Artificial intelligence technology is improving business analysis. A decade of investment in artificial intelligence, AI, and machine learning, ML, has boosted business growth on multiple fronts, such as the ability to turn text into images and tools that predict when deals will close and at what value. SMBs now have access to sophisticated operational, forecasting, and planning tools previously exclusive to large enterprises with coding teams. Kunal Madan, founder of online retailer Amara, believes data analytics can significantly bolster SMB efficiency. Analyzing customer behavior data can highlight peak purchasing times, allowing businesses to optimize their operational schedules, thus reducing costs, Madan explained. Detailed product performance data can inform targeted inventory management, preventing stockpiling and wastage. Here are a few examples of AI helping small businesses with data analysis. AI-powered employee performance analysis. Managers and supervisors can use AI analytics tools to assess employee performance, pinpointing why KPIs are missed and highlighting areas where specific training is needed. AI-powered decision-making. At the highest levels, CEOs are using decision support systems to tell them the likely result of a course of action they're considering, such as investments in machinery, which new markets to enter, and potential returns on product development. AI-powered retail management. AI data analytics for retailers can reduce the risk of ordering too many items or the wrong stock. It can even predict how much stock each shop and the online warehouse will need so customers aren't disappointed when shopping. The marketplace for AI plugins is growing quickly. AI-powered data analytics tools are available either as core or add-on services for numerous business apps. We expect SMBs to continue adopting this technology, as its insights will help business owners find rationalization and efficiency gains in a sluggish economy. Did you know? Machine learning in manufacturing is growing. Manufacturers use machine learning to check stock for defects as they roll off the production line. 2. Artificial intelligence tools are improving customer relationships. Sophisticated AI and ML tools rely on big data to parse and analyze information to better understand customer behaviors, preferences, and trends. Mary Zhang, head of marketing and finance at digital infrastructure provider DHTL Infra, says data-driven decision-making is crucial to improving customer relationships because it reduces bias and guesswork. When we shifted from gut feel to data-backed strategies in our marketing, we saw a 40% increase in campaign effectiveness, Zhang shared. The key is combining data insights with industry expertise for truly impactful decisions. Consider the following AI-powered technologies that businesses use to deepen customer connections. Deeper customer insights with natural language processing, NLP. NLP technologies allow businesses to extract valuable insights from customer interactions and social media mentions, so you can better understand the meaning and emotion hidden in transcribed phone calls, emails, live chats, and social media messages. When combined with sentiment analysis, NLP can recognize positive, negative, and neutral customer sentiments. Detect emotions like frustration, satisfaction, or excitement in your customers' words. Distinguish between statements, questions, suggestions, and compliments. One practical example of NLP in action is Amazon's Comprehend tool, which automatically summarizes consumer feedback on products and customer support interactions. This allows businesses to better understand customer sentiment and effectively address areas of concern. Improved customer service with conversational AI. Conversational AI tools, powered by live data, help businesses understand and respond to real-time customer needs. This technology gives businesses a constantly updated stream of data on what customers want to know, what excites them, and what concerns them. AI tools can also provide more effective and faster customer service at a fraction of the cost of traditional labor. Here are 2 examples of conversational AI in action. Live chat software. AI-driven chatbots can answer customer questions, suggest products, and solve issues instantly across your website, messaging apps, and social media channels. Call center solutions. The best call center software platforms use AI to manage calls, resolve technical issues, process orders, and provide support without human assistance. If a conversational AI tool encounters a question it can't answer, it transfers the customer to a human agent for follow-up and prompts the agent with on-screen suggestions to help find a solution. Enhancing data analytics with large language models, LLMs. Large language model, LLM, tools like ChatGPT offer real-time, intelligent responses through a chatbot interface. This technology is fundamentally different from the rules-based conversation tools that preceded it. Rules-based tools had the following drawbacks. They responded using keywords without any actual knowledge of what the customer was requesting. It was more of a best guess. They had no memory of a conversation. Every time the tool interacted with a customer, it was like it was the first time. While they stored conversational and interaction data, these tools were limited in understanding this data outside a keyword frame of reference. LLMs effectively address all of these points. They understand the context and intent behind customers' words and actions, making their responses more relevant to their needs. They can recall context across multiple applications and draw on a client's previous history, making the interaction far more personal. Their conversational and interactional analysis is far deeper, meaning they're able to grasp nuances, understand complex inquiries, and generate insightful responses that customers find genuinely helpful. LLMs also operate on a broader scale. They can perform deep contextual analysis on large datasets, not just individual customers. This means SMBs can more easily identify marketing trends, personalize their marketing, and run their business based on data-driven insights instead of gut instinct to stay competitive. 3. The DaaS and DSaaS markets are growing. Data as a Service (DaaS) and Data Security as a Service (DSaaS) are rapidly growing IT trends that help businesses efficiently store, analyze, and protect their data. DaaS, as data and data processing have shifted to the cloud, DaaS companies have gained popularity. These platforms offer businesses a broad range of powerful pre-built tools for analyzing data, allowing companies to gain insights without building complex infrastructure. Additionally, DaaS platforms provide opportunities for data monetization, enabling companies to share or sell their data to fill gaps in other businesses' databases. DSaaS. Protecting your business from cybercrime is an urgent priority, partly because companies are under increasing regulatory pressure to keep data safe and use it responsibly. DSaaS solutions address the complexities of protecting your business's sensitive information, especially when it's in transit or accessed through remote, unsecured devices. These services help businesses strengthen data privacy and reduce the risk of cyber threats by implementing robust security measures tailored to modern, cloud-based environments. FYI, the General Data Protection Regulation, GDPR, protects the online privacy of all EU citizens. Businesses must make their websites GDPR compliant to build trust and avoid downtime. 4. Data visualization tools are growing more sophisticated. Gathering data is necessary for business success and growth. However, how well you process and analyze that data is critical, affecting the quality of the decisions you make about your company's direction. Data visualization tools transform complex data into visual formats like charts, graphs, and dashboards, making it easier to understand and analyze. Many popular software packages, including the best CRM software and the best accounting software solutions, have powerful built-in visualization tools. However, specialized visualization packages are making data analysis even more effective, particularly when it involves large data volumes. Sensitive information, especially when it's in transit or accessed through remote, unsecured devices. These services help businesses strengthen data privacy and reduce the risk of cyber threats by implementing robust security measures tailored to modern, cloud-based environments. For example, Tableau is a popular data visualization tool that takes information from spreadsheets and databases and turns it into interactive charts and dashboards. These visuals can be shared across the organization to keep everyone informed and aligned. 5. Data monetization strategies are growing in popularity. Data monetization strategies help businesses make money or gain value from existing data. This can involve your business selling data to other companies, using it to create better products, or finding new commercial opportunities. Data monetization has internal and external approaches. Internal monetization involves using company data to improve decision-making, boost sales, enhance customer satisfaction, and reduce costs. External monetization involves sharing or selling data to third parties or pooling it with other companies in joint marketing campaigns. Ben Sporn, CEO of financial publisher Joy Aulett, emphasizes the importance of internal data monetization strategies for businesses. Small businesses can use data to analyze customer behavior and identify patterns that inform targeted marketing strategies, Sporn explained. Instead of spreading their marketing budget thin, they can focus on the most effective channels and customer segments, which can lead to better ROI. Data is an asset, and it makes commercial sense to monetize it. However, with the right strategy, you can unlock new revenue opportunities, build valuable partnerships, and better understand your customers. Tip: conduct a cybersecurity risk assessment to assess the safety of your data and consider applying a data minimization strategy to prevent the storage of data you don't need anymore. How can SMBs use data analytics? Consider the following 4 impactful ways SMBs are using data analytics. Data analytics helps SMBs improve closing rates. One of the main applications of machine learning for small businesses is tracking customers throughout the different stages of the sales cycle. Small businesses can leverage data analytics to identify specific customer segments who are ready to buy and, more importantly, when they'll be ready. Data analytics helps SMBs provide better customer service. AI-powered data analytics tools help provide an enhanced understanding of customers' needs and pain points, allowing SMBs to deliver personalized service. For example, as our RingCentral Omnichannel CX review explains, this platform's built-in sentiment analysis can record all phone calls, emails, and live chat conversations over the past 90 days, analyze them, and present its results as a word bubble. Businesses can see what issues impact customers and ensure agents respond appropriately. Data analytics helps SMBs identify and respond to trends. Businesses can leverage data analytics to identify overarching patterns and trends. For example, if numerous customers contact a business asking the same questions, creating an online knowledge base that addresses these questions in depth might make sense. This resource could even increase sales as it addresses common questions potential buyers face and helps strengthen a brand's unique selling proposition, USP. Data analytics helps SMBs better understand customer behavior. Data analytics provides detailed analyses of customer behavior, showing business owners what motivates consumers to buy their products or services. Sporn noted that analyzing customer behavior and identifying patterns allows SMBs to create targeted marketing strategies. For example, by using data from previous sales and website behavior, a small business can tailor its marketing campaigns to specific times of the year or customer needs, cutting waste and increasing efficiency, Sporn explained. Data analytics can be budget-friendly. Leveraging data analytics is cost-effective for SMBs. Consider the following affordable resources that can provide small business owners with a wealth of information. Website reporting tools. Google Analytics and Clicky offer website reporting with free and premium versions. These tools are ideal for tracking web traffic, helping you discern which marketing strategies are most effective, how visitors explore your site, potential friction points, and more. Wolfram Alpha. Wolfram Alpha is a computational intelligence platform with free and paid versions. It allows you to compute expert-level answers using its signature algorithms, knowledge base, and AI technology. Microsoft Power BI. Microsoft Power BI is a robust platform for generating visualized business data on everything from gross profit and revenue to store and warehouse demand and turnover. The Pro option costs $10 per user per month, making it affordable for most small businesses. AI-powered tools. AI-powered tools like ChatGPT and Claude can help businesses simplify complex data to identify patterns, trends, and solutions. AI tools can also support businesses with limited resources by automating tasks, such as data entry, freeing up more time for staff to focus on other essential tasks. Zhang stressed that SMBs getting started with data analytics have numerous options. We began with simple spreadsheet analysis and gradually moved to more sophisticated platforms like Google Analytics and Tableau, Zhang shared. These tools offer powerful insights without breaking the bank. Did you know? Data analysis insights can help reduce marketing and product development expenditures. Instead of funneling funds into multiple marketing efforts that yield minimal results, small businesses can pinpoint strategies proven to generate high-quality sales leads. How to get started with data analytics in your business. Integrating data analytics into business processes can be complicated, but it's worth it, according to Stuart Barber Yarborough, consulting business lead at global consulting firm Royal Haskell DHV. Before starting a data analytics project, be sure you have the following. Team members who understand data analysis. Easy-to-use software that can analyze your data efficiently. A constant data feed from other business apps into your data analysis software. Consider the following best practices for starting a data analytics project. Hold a planning meeting to set goals. Barber Yarborough stressed that any data analysis journey must support the business's overall strategy and goals and shouldn't be treated as a separate task. The key first step is a planning meeting where you look at where your business is now, where you want it to be, and the pain points or gaps that will confront you before you get there, Barber Yarborough advised. Get your team on board. After setting your goals, it's time to get your staff engaged with the project. You must communicate the benefits their work will bring to the business. Work with your team to identify high-priority tasks that will get buy-in and enthusiasm from your staff, Barber Yarborough recommended. If they don't see the vision and the end goal, they'll view this data project and others as nothing more than extra work for them. Identify the data you want to analyze. A data analysis project must use key metrics, like KPIs and customer satisfaction data, that provide insights into performance. By having a clear picture of the ways you're improving and defining a basic project goal, you can identify the data that's most important for your project's success, Barber Yarborough explained. Collect and analyze relevant data. Initially, you should focus on collecting and analyzing only the most relevant data. This will prevent your team from getting bogged down with unnecessary information and adding greater complexity to the project. As you go on, you can collect and analyze more detailed data, but always be selective about the data you include. Choose the right data analysis tools. Barber Yarborough advises starting a data analysis journey with straightforward, widely used software like Excel. This lets people begin without needing specialized software, Barber Yarborough explained. Later on, you can use more complex apps and software to help uncover important insights more easily. Tools providing clear visual reports are ideal. Whatever apps and software you choose, try to make sure they are easy for project team members to use so they spend their time productively, rather than struggling to use them, Barber Yarborough added. Data analytics will keep transforming business. Data analytics can bring transformative insights to businesses. Bruce Jung, founder and CEO of strategic valve manufacturer NTVL, shared how data analysis helped transform the company from a small local firm to an international provider. The business analyzed its production cycle and discovered it overstocked 30 metric tons of raw materials annually. It adjusted its order cycles and saved more than $150,000 in inventory holding costs. We used Excel to track daily production rates and find inefficiencies, Jung explained. Tracking these metrics could reduce downtime by 60 hours per month and save about $20,000 in labor and missed deadlines. The company now uses AI-driven tools to forecast valve demand. It also identified $300,000 in savings by optimizing its supply chain and restructured its capacity to produce an extra 10,000 units a week, generating additional revenues of $500,000 a year. With results like these, it's no surprise that 93% of businesses plan to increase investments in data and analytics, according to an EY study. The trends mentioned here indicate a swift evolution of data analytics and demonstrate their power to transform multiple aspects of operations. Whether it's mimicking the human brain's knowledge acquisition through machine learning and deep learning or capitalizing on unused dark data to gain a competitive edge, the new era of data analytics has intensely practical applications that businesses should not overlook. This topic delved further into the impact of data analytics throughout the organization and the requirement to demonstrate value added from the investment in data analytics capabilities. The topic began with an extensive discussion of the types of data value obtained from data analytics implementation in various functional areas of the traditional business value chain. Next, we examined 10 real-world used cases in a variety of industries. The topic concludes with an examination of the benefits of business intelligence applications in small businesses. The topic describes the career opportunities in business analytics, which might not be a personal interest at this time, but may become a managerial responsibility as you build the data analytics capabilities within your organization. The topic begins with an example of a data analyst certification course from Google, which explains the recruitment and interview process cloud-based data analysts will encounter. Next, we look at the various day-to-day tasks done in data analytics and the variety of skills and tools used in decision support. The topic concludes with descriptions of 15 career paths in data analytics and related areas and the job descriptions and current salary ranges for these positions. What does a data analyst do? Your 2026 career guide. Data analysts collect, clean, and interpret data sets to solve problems or answer questions, such as, what kind of customer should a business target in its next ad campaign? What age group is most vulnerable to a particular disease? What patterns in behavior are connected to financial fraud? Data analysts work in many industries, including business, finance, criminal justice, science, medicine, and government. In this article, we'll discuss more about what data analysts do, what skills you'll need to pursue this career, and how you can start on a path to becoming one. Afterward, if you want to start working toward a data career by building job-relevant skills and earning a respected credential, consider enrolling in the Google Data Analytics Professional Certificate. What is data analysis? Data analysis is the process of gleaning insights from data to inform better business decisions. The process of analyzing data typically moves through 5 iterative phases. Identify the data you want to analyze. Collect the data. Clean the data in preparation for analysis. Analyze the data. Interpret the results of the analysis. Data analysis can take different forms, depending on the question you're trying to answer. Descriptive analysis tells us what happened. Diagnostic analysis tells us why it happened. Predictive analytics forms projections about the future. And finally, prescriptive analysis creates actionable advice on what actions to take. Data analyst tasks and responsibilities. A data analyst gathers and interprets data in order to solve a specific problem. The role involves plenty of time spent with data, but also entails communicating findings to stakeholders. Here's what many data analysts do on a day-to-day basis. Gather data. Analysts often collect data themselves. This could include conducting surveys, tracking visitor characteristics on a company website, or buying datasets from data collection specialists. Clean data. Raw data might contain duplicates, errors, or outliers. Cleaning the data means maintaining the quality of data in a spreadsheet or through a programming language so that your interpretations won't be wrong or skewed. Model data. This entails creating and designing the structures of a database. You might choose what types of data to store and collect, establish how data categories are related to each other, and work through how the data actually appears. Interpret data. Interpreting data involves finding patterns or trends in data that could answer the question at hand. Present, communicating the results of your findings will be a key part of your job. You do this by putting together visualizations like charts and graphs, writing reports, and presenting information to interested parties. What tools do data analysts use? During the process of data analysis, analysts often use a wide variety of tools to make their work more accurate and efficient. Some of the most common tools in the data analytics industry include Microsoft Excel, Google Sheets, SQL, Tableau, R or Python, SAS, Microsoft Power BI, Jupyter Notebooks. Learn how to perform data analysis, including data preparation, statistical analysis, and predictive modeling using R, RStudio, and Jupyter in the IBM Data Analytics with Excel and our Professional Certificate. Professional Certificate. IBM Data Analytics with Excel and R. Prepare for a career in data analytics. Gain the in-demand skills and hands-on experience to get job ready in less than 3 months. No prior experience required. 4.7. 2,841 ratings. 64,623 already enrolled. Beginner level. Average time, 3 months. Learn at your own pace. Skills you'll build. Excel formulas, data storytelling, data analysis, Shiny, R package, data manipulation, big data, interactive data visualization, data presentation, ggplot2, data visualization, web scraping, analytical skills, data wrangling, database design, data visualization software, exploratory data analysis, dashboard, IBM Cognos Analytics, relational databases, Microsoft Excel, data quality, pivot tables and charts, data cleansing, data import, export, data science, data integrity, Google Sheets, spreadsheet software, information privacy, Tidyverse, R package, data collection, regression analysis, predictive modeling, data transformation, statistical modeling, predictive analytics, R programming, statistical analysis, machine learning methods, feature engineering, leaflet software, histogram, scatter plots, user interface, UI, box plots, plot, graphics, UI components, spatial data analysis, data lakes, Apache Spark, Apache Hive, data warehousing, Apache Hadoop, tree maps, Looker, software, SQL, databases, database management systems, query languages, data analysis software, data modeling, data access, database management, data structures, programming principles, Jupyter. Integrated development environments. Data analyst salary and job outlook. The average base salary for a data analyst in the U.S. is $74,052 as of June 13, 2025, according to Glassdoor. This can vary depending on your seniority, where in the U.S. you're located, and other factors. Data analysts are in high demand. The World Economic Forum listed them as one of the fastest-growing jobs between 2025 and 2031. The U.S. Bureau of Labor Statistics, BLS, also reports that related occupations have extremely high growth rates. From 2023 to 2033, operations research analyst positions are expected to grow by 23%, data scientists by 36%, market research analysts by 8%, and mathematicians and statisticians by 11%. That's a lot higher than the total employment growth rate of just 4% over the decade. Data analyst versus data scientist. What's the difference? Data analysts and data scientists both work with data, but what they do with it differs. Data analysts typically work with existing data to solve defined business problems. Data scientists build new algorithms and models to make predictions about the future. Learn more about the difference between data scientists and data analysts. Types of data analysts. As advancing technology has rapidly expanded the types and amount of information we can collect, knowing how to gather, sort, and analyze data has become a crucial part of almost any industry. You'll find data analysts in the criminal justice, fashion, food, technology, business, environment, and public sectors, among many others. People who perform data analysis might have other titles such as medical and healthcare analyst, market research analyst, business analyst, business intelligence analyst, operations research analyst, intelligence analyst. Interested in business intelligence? Gain the business and data skills you need for an entry-level business analyst role with IBM's Business Analyst Professional Certificate Program. In as little as 3 months, you'll gain critical skills like business systems analysis, project risk management, and interactive data visualization. Professional Certificate. IBM Business Analyst. Get job ready as a business analyst. Build the essential skills, technical expertise, and hands-on experience with key business analysis tools. 4.7. 608 ratings. 35,574 already enrolled. Beginner level. Average time, 3 months. Learn at your own pace. Skills you'll build. Excel formulas, risk mitigation, data storytelling, responsible AI, business analytics, prompt engineering, business requirements, project scoping, interactive data visualization, data presentation, data visualization, digital transformation, stakeholder management, process optimization, process flow diagrams, business analysis, stakeholder analysis, risk analysis, Microsoft Excel, business process modeling, project management, risk management, communication strategies, stakeholder engagement, communication, plan execution, stakeholder communications, requirements analysis, project coordination, project planning, generative AI, requirements elicitation, artificial intelligence, data-driven decision-making, workflow management, business process automation, data analysis, data quality, data manipulation, pivot tables and charts, data cleansing, data import, export, data science, data integrity, Google Sheets, spreadsheet software, information privacy, data wrangling, gap analysis, change management, analysis, systems analysis, technology strategies, dashboard, histogram, tree maps, IBM Cognos Analytics, scatter plots, Looker, software, data visualization software, scope management, work breakdown structure, presentations, data analysis software, requirements management, ethical standards and conduct, business process, needs assessment, user story, agile methodology, process improvement, data modeling, process analysis. How to become a data analyst. You can find data analytics jobs in all sorts of industries, and there's more than one path toward securing your first job in this high-demand field. Whether you're just getting started in the professional world or pivoting to a new career, here are some steps toward becoming a data analyst. 1. Get a foundational education. If you're new to the world of data analysis, you'll want to start by developing some foundational knowledge in the field. Getting a broad overview of data analytics can help you decide whether this career is a good fit while equipping you with job-ready skills. It used to be that most entry-level data analyst positions required a bachelor's degree. While many positions still do require a degree, that's beginning to change. You can develop foundational knowledge and enhance your resume with a degree in math, computer science, or another related field, or you can also learn what you need through alternative programs like professional certificates, boot camps, or self-study courses. Resources to start your data analyst career. We've curated a collection of resources to help you decide whether becoming a data analyst is right for you, including figuring out what skills you'll need to learn and courses you can take to pursue this career. 2. Build your technical skills. Getting a job in data analysis typically requires having a set of specific technical skills. Whether you're learning through a degree program, professional certificate, or on your own, these are some essential skills you'll likely need to get hired. Statistics. R or Python programming. SQL, structured query language. Data visualization. Data cleaning and preparation. Take a look at some job listings for roles you'd like to apply for and focus your learning on the specific programming languages or visualization tools listed as requirements. In addition to these hard skills, hiring managers also look for workplace skills, like solid communication skills. You may be asked to present your findings to those without as much technical knowledge, problem-solving ability, and domain knowledge in the industry you'd like to work. Learn more. 7 in-demand data analyst skills to get hired. Professional certificate. Microsoft Data Visualization. Develop skills in data analysis and visualization. Build job-ready skills for an in-demand career in data visualization in as little as 3 months. No prior experience or degree required to get started. 4.8. 108 ratings. 15,251 already enrolled. Beginner level. Average time, 4 months. Learn at your own pace. Skills you'll build. Business intelligence, data storytelling, data architecture, data analysis, Power BI, data governance, data analysis expressions, DAX, interactive data visualization, data presentation, data visualization, extract, transform, load, database design, data visualization software, correlation analysis, dashboard, data modeling, data cleansing, data ethics, data transformation, statistical analysis, data security, performance analysis, data-driven decision-making, key performance indicators, KPIs, business analytics, data management, business reporting, performance tuning, Snowflake schema, STAR schema, data integrity, information privacy, data quality, relational databases, data storage, data integration, data processing, data import, export, data validation, data wrangling, root cause analysis, time series analysis and forecasting, geospatial information and technology, scatter plots, forecasting, analytics, trend analysis, advanced analytics, exploratory data analysis, statistical, visualization, histogram, pivot tables and charts. 3. Work on projects with real data. The best way to learn how to find value in data is to work with it in real-world settings. Look for degree programs or courses that include hands-on projects using real data sets. You can also find a variety of free public data sets you can use to design your own projects. Dig into climate data from the National Centers for Environmental Information, delve deeper into the news with data from BuzzFeed, or come up with solutions to looming challenges on Earth and beyond with NASA Open Data. These are just a few examples of the data out there. Pick a topic you're interested in and find some data to practice on. Read more. 5 data analytics projects for beginners. 4. Develop a portfolio of your work. As you play around with data sets on the internet or complete hands-on assignments in your classes, be sure to save your best work for your portfolio. A portfolio demonstrates your skills to hiring managers. A strong portfolio can go a long way toward getting the job. As you start to curate work for your portfolio, choose projects that demonstrate your ability to. Scrape data from different sources. Clean and normalize raw data. Visualize your findings through graphs, charts, maps, and other visualizations. Draw actionable insights from data. If you've worked on any group projects through the course of your learning, consider including one of those as well. This shows that you're able to work as part of a team. If you're not sure what to include in your portfolio or need some inspiration for project ideas, spend some time browsing through other people's portfolios to see what they've chosen to include. Read more. How to build a data analyst portfolio. Tips for success. 5. Get an entry-level data analyst job. After gaining some experience working with data and presenting your findings, it's time to polish your resume and begin applying for entry-level data analyst jobs. Don't be afraid to apply for positions that feel like a stretch. Your skills, portfolio, and enthusiasm for a role can often matter more than if you check every bullet item in the qualifications list. If you're still in school, ask your university's career services office about any internship opportunities. With an internship, you can start gaining real-world experience for your resume and apply what you're learning on the job. There's more than one path toward a career as a data analyst. Whether you've just graduated from school or are looking to switch careers, the first step is often assessing what transferable skills you have and building the new skills you'll need in this new role. 6. Consider certification or an advanced degree. As you move through your career as a data analyst, consider how you'd like to advance and what other qualifications can help you get there. Certifications, like the Certified Analytics Professional or Cloud-Era Certified Associate Data Analyst, may help qualify you for more advanced positions at higher pay grades. If you're considering advancing into a role as a data scientist, you may need to earn a master's degree in data science or a related field. Advanced degrees are not always required, but having one can open up more opportunities. Data analyst career advancement. Being a data analyst can also open doors to other careers. Many who start as data analysts go on to work as data scientists. Like analysts, data scientists use statistics, math, and computer science to analyze data. A scientist, however, might use advanced techniques to build models and other tools to provide insights into future trends. Further your data analytics career with the Google Advanced Data Analytics Professional Certificate. 15 Careers in Data Analytics, Exploring Your Future in Data. The job title of data analyst is something of a misnomer. While there are plenty of jobs with this title on job boards like Indeed, there are so many other titles that fall under the larger umbrella of data analytics. Data can be used in so many different ways to shape business decisions. Likewise, each job in data analytics requires a unique set of skills and offers its own challenges and rewards. So if you're considering a career in data analytics, then it's important to know the difference between all of these different roles. Luckily, you're already in the right place. In this article, we're breaking it all down for you. We'll take you through 15 roles in the field, looking at what each job requires, the skills you need, and where it could take you in your career journey. If you've ever been curious about finding your place in the world of data analytics, you're in the right spot. Let's help you find your fit. Data analytics careers to consider. Here are some of the most popular data analytics careers to consider and what each entails. Data analyst. Data analysts bridge the gap between the technical world of data and the practical needs of the business. They do this by analyzing huge amounts of data from various sources to reveal patterns, relationships, and trends. This could be done for determining business decisions or even predicting future events. Skills and tools. On the technical front, a good data analyst has a strong grasp of SQL, Python, R, and other data manipulation languages. Spreadsheet software like Excel remains a staple, but more specialized tools like Tableau or Power BI are often used for visualization. They should have previous experience with statistical analysis, data cleaning, and data visualization, as one of their responsibilities is to take raw, unstructured data and turn it into an easy-to-read format. Average salary. The average salary of a data analyst varies by region and experience, but in the U.S., they earn between $62,000 and $97,000. Career growth path. You can advance to a senior or lead analyst position when you gain more experience and expertise as a data analyst. After that, many move on to specialized roles like data scientists. If you want to go the entrepreneurial route, you can leverage your analytical expertise to transition into consulting roles. Information Security Analyst. Information security analysts work behind the scenes to make sure that an organization's digital assets are protected from breaches and cyber attacks. They constantly monitor networks for suspicious activity and update software with the latest security measures. While many might see them primarily as defenders against external threats, they also play an important role internally. They help create a culture of security awareness among the members of an organization by training staff and collaborating with different departments. Skills and tools. Security analysts need to understand network configurations, operating systems, and encryption techniques. They always rely on software solutions to help them. This includes intrusion detection systems like Snort, vulnerability scanning tools like Nessus, and advanced cybersecurity platforms like Splunk. Average salary. An information security analyst earns a median salary of $102,600 per year. Career growth path. Information security analysts can aspire to roles such as security engineer, security architect, or even chief information security officer, CISO, of an organization. Beyond vertical growth, the skills you develop can also lead you to specialized paths like penetration testing, cyber threat intelligence, or security consultancy. Statistician. A statistician is, first and foremost, an expert in data. They can extract meaningful insights from complex datasets. With their expertise, statisticians provide valuable input into the decision-making process, whether predicting future market trends, assessing the efficacy of a new drug, or shaping public policies. Skills and tools. Statisticians need a solid foundation in mathematics and statistical theory and proficiency in programming languages such as R, Python, or MATLAB. For data analysis, statisticians use software like SPSS or SAS. R or Python statistical libraries are often helpful for more specialized tasks. Average salary. Statisticians can earn an average salary of $97,535 annually, depending on their expertise. Career growth path. As a statistician, you can gravitate towards senior data roles, perhaps even branching into specialized areas like biostatistics or econometrics, or you can transition into academia and share your knowledge with others. Data scientist. While data analysts make sense of the data they're collecting, data scientists work to find new ways to capture that data. They design data modeling processes to create algorithms and predictive models and apply advanced machine learning techniques to gather insights from the data they're collecting. Skills and tools. Data scientists need extensive machine learning, statistics, and data mining knowledge. They use platforms like TensorFlow or PyTorch for deep learning. When coding, they use Jupyter Notebooks, RStudio, or similar IDEs. Integrated development environments. Average salary. In the U.S., the average salary of a data scientist is $106,383 per year. Career growth path. From an entry-level data scientist, the progression can lead to senior or lead data scientist roles. With time and experience, you could aspire to roles like Chief Data Officer or Director of Data Science. Business Intelligence Analyst. Business intelligence analysts need to stay up to date with any market trends to assist in strategic business planning. Often collaborating with stakeholders, they design, develop, and maintain BI dashboards and reports. They recommend process improvements throughout a project and base their advice on data-driven insights. Skills and tools. From a technical perspective, business intelligence analysts need proficiency in SQL for database querying and a strong understanding of data warehousing concepts. For more experienced business intelligence analysts, proficiency in statistical methods and analysis is of even greater importance. Average salary. The average salary of a BI analyst is around $125,209 per year. Career growth path. The analytical skills you develop as a business intelligence analyst can pave the way for roles such as Senior Business Intelligence Analyst, Business Intelligence Manager, or Director of Business Intelligence. Data Assurance Analyst. A data assurance analyst must ensure an organization's data remains accurate and reliable. They implement measures to detect and rectify errors, and their roles extend beyond quality control to education, strategy, or policy setting. Skills and tools. Knowledge of data regulations and compliance, such as GDPR or CCPA, is essential, depending on the industry. In terms of tools, data assurance analysts frequently use data quality software like Informatica Data Quality, Talend, or IBM InfoSphere Quality Stage to help them with data profiling, integration, validation, and cleansing. Average salary. A data assurance analyst earns an average salary of $73,540 per year. Career growth path. Given the emphasis on data-driven strategies, you have the potential to transition to broader roles in data analytics or data governance. However, roles to pursue as a data assurance analyst include Senior Data Assurance Analyst or Data Quality Manager. Data Quality Analyst. A data quality analyst has similar responsibilities to that of a data assurance analyst. They must be proactive and set and maintain the gold standard for data. From monitoring data imports to guiding teams on best data management practices, their influence spans the entirety of the data lifecycle. Skills and tools. Data quality analysts use tools like Informatica or Trillium to assess and improve data quality. They need a strong understanding of data profiling and cleansing and should have knowledge of SQL for querying and data manipulation. Average salary. The average salary for a data quality analyst is $78,902 per year. Career growth path. If you want to progress in your career as a data quality analyst, you can explore roles such as Senior Data Quality Analyst or Data Scientist. As virtually all businesses need to analyze and make sense of data, you can branch out into different industries. Financial Data Analyst. A financial data analyst is essential in making business decisions, including forecasting future trends and generating detailed financial reports. The financial data analyst ensures that a company's monetary decisions are always informed, strategic, and forward-looking, whether assessing potential investments or collaborating closely with the finance team on budgetary matters. Skills and tools. Financial data analysts are proficient in statistical analysis and understand financial principles. They should be able to use spreadsheet software, including knowledge of complex formulas, and be familiar with SQL, which can be a significant advantage for database querying. Average salary. On average, financial data analysts earn $80,764 per year. Career growth path. Choosing a path as a financial data analyst can open tons of doors for you in the finance industry. With experience, you can progress to roles like Senior Financial Analyst or Financial Data Manager. Positions such as Director of Financial Planning and Analysis or even Chief Financial Officer, CFO, are achievable targets. Marketing Data Analyst. Marketing data analysts have various responsibilities within the marketing department, including but not limited to tracking digital campaigns, forecasting sales, and analyzing customer behavior. They often study how customers interact with brands and design and analyze A/B testing experiments to determine the effectiveness of different marketing strategies. Skills and tools. To perform the above tasks, depending on the experience of the marketing data analyst, they might use various tools and techniques. They often work with analytical platforms like Google Analytics and tools for A/B testing like Optimizely. They might also work with CRM platforms, SQL databases, and marketing automation tools, transitioning between them to gather and analyze data. Average salary. Depending on their industry, marketing data analysts can earn an average salary of $71,342 yearly. Career growth path. Marketing data analysts have a variety of options when it comes to career progression. Besides advancing to managers or CMOs, they can also start their own consultancy business or explore related careers, such as CRO specialists. Sales data analyst. Within sales, a sales data analyst collaborates closely with marketing data analysts to predict future sales volumes and revenue and classify customers into distinct categories based on purchasing behavior. They also monitor and evaluate the performances of sales reps against set targets. If any areas require improvement, they work with the sales team to offer them data-driven feedback and suggestions. Skills and tools. Familiarity with CRM systems like Salesforce or HubSpot is essential in this role. Sales data analysts also need proficiency in data visualization tools such as Tableau or Power BI and a good grasp of spreadsheet software. Advanced analysts also utilize programming languages like Python or R for more complex analyses. Average salary. The average salary of a sales data analyst is $71,620 per year. Career growth path. In such a competitive field, sales data analysts often need a proven track record to get roles, such as Director of Sales Operations or VP of Sales Analytics. Each promotion offers a broader scope of responsibility, but is highly rewarding, as sales data analysts almost always earn bonuses or commissions. Healthcare data analyst. Data analysts operating in the healthcare industry have a variety of roles and responsibilities. They mainly harness the power of data to improve patient outcomes and streamline healthcare professionals' day-to-day operations. Their responsibilities include ensuring healthcare institutions comply with regulations, optimizing EHR systems, and keeping an eye on the financials. Skills and tools. Becoming a healthcare data analyst requires you to have a combination of technical proficiency and domain-specific knowledge. You need a strong familiarity with healthcare regulations and processes. Soft skills like communication and teamwork are invaluable, given the collaborative nature of the role. Key tools in a healthcare data analyst's arsenal include specialized software tailored for the healthcare industry, such as EHR systems like Epic or Cerner. Average salary. Healthcare data analysts earn an average salary of $88,107 per year. Career growth path. With a few specialized certifications under your belt and years of experience as a healthcare data analyst, you can become a manager of data science at a healthcare organization. You could also work as a consultant with healthcare institutions if you've made enough connections throughout the years. Operations analyst. An operations analyst represents the connection between data and business processes. They need to make sure an organization runs as smoothly and efficiently as possible by creating processes and helping team members avoid inefficiencies and bottlenecks. They keep a vigilant eye on performance metrics and understand the nuances of various departments. Skills and tools. To be a successful operations analyst, you need strong analytical skills complemented by attention to detail and proficiency in various technical skills such as data visualization, statistical analysis, and an understanding of operational principles. You will rely on tools like Microsoft Excel and SQL, but also need familiarity with process mapping tools such as Microsoft Visio. Average salary. An operations analyst earns an average salary of $64,317 per year. Career growth path. A senior operations analyst or operations manager may aspire to positions that require increased responsibilities, including strategic planning and higher-level decision-making. As you climb the corporate ladder, you can reach positions such as Director of Operations or Chief Operating Officer, COO. Data Visualization Specialist. Data visualization specialists turn complex data sets into visually appealing narratives. When raw data is overwhelming, they sift through vast amounts of information and craft a visual story understandable by both technical and non-technical stakeholders. Skills and tools. Besides the obvious foundation in statistics and data analysis, data visualization specialists also need knowledge of design principles, color theory, and graphic design. They use tools such as Tableau, Power BI, D3.js, and Adobe Illustrator. Basic knowledge of programming languages, especially those related to web development like HTML, CSS, and JavaScript, can also be advantageous. Average salary. The average salary of a data visualization specialist is around $79,141 per year. Career growth path. Often transitioning from a previous graphic design-related career, data visualization specialists have many transferable skills. They can progress to roles such as Senior Data Visualization Designer or Visualization Lead, where they'll have more influence over projects and potentially lead a team. Machine Learning Engineer. One of the most sought-after roles in the tech industry today, machine learning engineers craft intelligent systems and algorithms capable of learning from and making database decisions. They develop models to process, predict, and analyze data with minimal human intervention. Skills and tools. A machine learning engineer needs a deep understanding of algorithms, statistics, and mathematics and knowledge of programming languages such as Python, R, or Java, with Python being the most popular. They master frameworks and libraries like TensorFlow, Keras, PyTorch, and Scikit-learn. Average salary. A machine learning engineer earns an average salary of $123,129 per year. Career growth path. In addition to taking on increased responsibilities and overseeing large teams, machine learning engineers may progress to become senior machine learning engineers or lead machine learning engineers. In addition to engineering, it is possible to transition into research-focused roles, such as chief data scientist or machine learning researcher. Big data engineer/architect. Big data engineers and architects are tech-savvy and responsible for creating the blueprints of big data systems and overseeing their implementations. They integrate disparate data sources and use data integration tools to make sure that data flows seamlessly through the pipelines they've built. They also provide solutions for streaming massive amounts of data. Skills and tools. To excel as a big data engineer/architect, you need a deep understanding of databases and big data technologies such as Hadoop, Spark, and NoSQL. Mastery of languages like Java, Python, and Scala is essential due to their extensive use in big data technologies. Knowledge of ETL tools like Apache NiFi or Talend and data warehousing solutions can also give you an advantage. Average salary. Big data engineers/architects generally earn an average salary of $180,211 per year. Career growth path. As a big data engineer or architect, you have already taken a significant step forward in your career. You may advance to a position like Senior Big Data Architect or Chief Data Officer as you gain expertise and experience. Get to know other data analytics students. Nelson Borges, Insights Analyst at LinkedIn. Bart Towin, Global Business Analyst, Global Talent Intelligence, GTI, at Meta. Sarah Ganahar, Business Intelligence Analyst at Amazon Web Services. Skills every data analyst will need. Regardless of an analyst's path, every aspiring analyst must possess a core set of skills. First and foremost, you need statistical analysis skills to discern patterns, identify anomalies, and make informed predictions from vast datasets. Statistical know-how and proficiency in programming languages such as Python or R is also needed. In addition to the technical foundation, it is also important to be able to communicate findings. This is where the soft skill of effective communication comes into play. As a data analyst, you'll often find yourself in the middle of technical experts and non-technical stakeholders. Bridging this gap requires a talent for translating complex data-driven insights into actionable recommendations. Data analyst career paths: where to start. Depending on your experience level or the industry you come from, there are a few starting points that you can follow to pursue a career in data analytics. In this section, we look at some steps you can take based on where you currently stand. You're just getting into data. If you're a newcomer to the world of data analytics, begin by arming yourself with foundational knowledge on online platforms such as Coursera, edX, and Udemy. For those who thrive in structured learning environments, try enrolling in a data analytics bootcamp, such as Springboard's Data Analytics Bootcamp. These intensive programs can fast-track your skills in a few months and at a fraction of the cost of a traditional degree. At the same time, don't be scared to get your hands dirty with real data. Platforms like Kaggle offer datasets and challenges that allow you to apply and hone your budding skills practically. You've got direct experience. With direct experience, perhaps from roles in business analytics or from routinely wrestling with Excel formulas, you're already a step ahead in the data game. Leverage your existing know-how by focusing on expanding your skill set to include more advanced tools and techniques. Extend your knowledge of programming languages such as Python or R to automate tasks to handle larger datasets, and try to master data visualization tools. Remember to constantly update your portfolio with complex projects as you move along. You've got indirect experience. Possessing indirect experience, say from roles where data wasn't your primary focus, but you still interacted with it, offers a unique advantage. Your understanding of business contexts or industry-specific challenges is a great asset. Start by identifying gaps in your technical knowledge and address them through online data analytics courses or workshops. Network with data professionals in your industry, as their insights can guide you on which skills are most sought after. FAQs about pursuing a career in data. We answer your most frequently asked questions. What is the difference between a data scientist and a data analyst? Both data scientists and data analysts work with data. But while a data analyst focuses on interpreting data to provide actionable insights, a data scientist not only analyzes data, but also uses advanced statistical techniques, including machine learning, to find new ways of capturing that data. Do you need a degree to get into data analytics? A degree is not required to break into data analytics. The field values practical skills and real-world problem-solving abilities. Many successful data professionals have transitioned from diverse backgrounds through online courses, boot camps, workshops, and self-study. Which industries hire the most data professionals? The tech sector is at the forefront, with giants like Google, Amazon, and Facebook constantly hiring. The finance, banking, healthcare, e-commerce, and retail sectors also rely extensively on data analytics. How do roles like machine learning engineer and big data engineer fit into the data analytics landscape? The titles of machine learning engineer or big data engineer are specialized roles within the broader data analytics ecosystem. A machine learning engineer focuses on designing, implementing, and deploying machine learning models that can learn and make decisions from data. In many ways, their work overlaps with data scientists, but with a heavier emphasis on the engineering and deployment aspects. Meanwhile, big data engineers are responsible for designing, maintaining, and enabling large-scale processing systems to make data accessible to analysts and scientists. Build your data analyst skills today. Data analysts use their knowledge to help others make more informed decisions. Build the skills you need for this in-demand and fast-growing career through one of these educational programs on Coursera. To prepare for an entry-level data analyst role, enroll in the Google Data Analytics Professional Certificate. In this beginner-level program, you'll learn how to clean, organize, analyze, visualize, and present data from data professionals at Google. To launch your career as a Power BI analyst, take the Microsoft Power BI Data Analyst Professional Certificate. In as little as 5 months, you'll learn to use Power BI to connect to data sources, explore the visualization and reporting capabilities of Power BI, and prepare Excel data for analysis in Power BI. For data analysis and visualization skills, explore the Microsoft Data Visualization Professional Certificate. Learn how to create data visualizations, build data models, and prepare and transform datasets. The topic described the career opportunities in business analytics, which might not be a personal interest at this time, but may become a managerial responsibility as you build the data analytics capabilities within your organization. The topic began with an example of a data analyst certification course from Google, which explains the recruitment and interview process cloud-based data analysts will encounter. Next, we looked at the various day-to-day tasks done in data analytics and the variety of skills and tools used in decision support. The topic concluded with descriptions of 15 career paths in data analytics and related areas and the job descriptions and current salary ranges for these positions. This topic includes both a summary of the work we have accomplished and an invitation for continued professional development in data analytics, data science, machine learning, and artificial intelligence. The topic begins with a book review of a popular data analytics for managers textbook published by Harvard Business Review that would be a great resource for your continued professional development. Next, we present a data analytics/data science short course, which is a great review of some topics we have covered in the course and a look at emerging tools and technologies for data analytics, including R and Python and other database and data science topics. HBR, Data Analytics Basics for Managers, 2018. By Consultants Mind 3 comments. Good decisions require data. Of course. Without some robust thinking and analysis based on data, it's called, guessing. Even if you are not a quant, you better be able to explain what a regression is and roughly how it works. Look, we've all forgotten a lot of undergraduate statistics, but trust me, it's useful to know what a p-value is. How data analytics-ish are you? Take a look at the spectrum I created below. Where are you, and more importantly, where should you be for your work? Left, willful detractor/cynic/curmudgeon of data analytics. Right, enthusiastic savant/GitHub-fueled evangelist. I am a proud liberal arts major, but not so proud about my illiteracy in Python, R, JavaScript, and HTML. Dang, that's a long list. That said, I am not a Luddite. As a B-school teacher, I understand the vast opportunities on the right. As a manager, I need to be able to lead people who live on the right. As a participant in the technology-first economy, I am the red triangle moving to the right. The world is awash as data. Recently read a book The Future is Faster Than You Think, P. Diamandis, S. Kotler, 2020 here, affiliate link, and they make the case that we are at the convergence of multiple exponential technologies because computing, faster and cheaper, plus storage, cheaper, plus machine learning algorithms, getting smarter every day. Perhaps you don't need convincing of this fact, but some acronyms driving this big bang in data. RP, Enterprise Resource Planning. The big SAP and Oracle investments from 10+ years ago are finally paying off. IoT, Internet of Things. Yes, your watch, light bulbs, front door, car are all spinning off data. OCR, Optical Character Recognition, of images and NLP, natural language processing of voice. Keeps improving. DDC, direct to consumer. Everyone wants a relationship with you. Read, data link with your phone. API, application programming interface. Keep getting closer to nirvana of plug and play software integration. What are the basics you need to know? I recently read the HBR guide, Data Analytics Basics for Managers here, affiliate link. It's 223 PG, 22 articles, and thankfully current, 2018. Please find some of my key takeaways from a non-quant perspective. 1. Clarify the purpose, why, before starting. Unless you are downloading a standardized canned report, there's going to be some ambiguity in the process. What data? What time range? What confidence level? Who can help me pull the data? What does clean data look like? The more you vet these questions in your own head, the less wasted time and uber frustration you are going to feel. So, take a minute and crystallize your thinking. It's okay to go slow, so you can go faster later. 2. Keep it simple. Can you explain it to your cousin? For those of us who work in Fortune 500 or consulting firms with dedicated analytics functions, it's easy to be enamored by all the whiz-bang talk of data lakes, Hadoop, and Snowflake. It's cool, mysterious, almost a siren call. Yo, Ulysses, wake up. Even if you don't do the analysis, you need to understand it. As Deloitte CFO Frank Friedman said, if I cannot articulate it, I cannot defend it to others. This is a crazy direct and useful piece of advice. Don't go admin and become a consulting mailman who just pretties up the numbers on a PowerPoint slide. Great story. Apparently, the CEO of TD Bank, Canada, insisted that managers be able to explain the math behind their financial products, and as a result, they largely avoided the arcane, toxic, leverage derivative products that lead to the financial crisis of 2008. 3. Stay intellectually honest. Getting useful insights takes effort and often failure. Hypothesis-based consulting is usually the right approach because you cannot analyze everything. It's the smart way to go, and yet it also means that you're often proven wrong. Think, null hypothesis. So, it can be tempting to take shortcuts. Just use the data you have. Just remove a few outliers that make no sense. Just do it. Confession time. We have all been guilty of torturing data until it says what we want. So, as professionals, let's commit to a plan and stick with it. Be transparent about the approach, number of observations, time, variables. Let's not run the experiment until we get the results we want, replication bias. Let's allow dead ends die. Instead, stay curious and test out a different hypothesis. Trust me, this is actually harder than it sounds. Think confirmation bias, overconfidence bias, overfitting bias, etc. 4. Be familiar enough with regression analysis. HBR describes regression analysis as the workhorse of analytics, so we better have some working idea of what it is and how to use it. Here is a 3-bullet point version. As you can imagine, there are entire courses on Coursera on the topic, so consider this the Twitter version. Official version. Regression analysis is a statistical technique to determine the relationship between a single dependent variable, criterion, and one or more independent, predictor, variables. Less wonky version. Regression analysis mathematically helps you understand to what extent A, B, C, D affect X. No regression will be perfect, so there will be an error term. As you might imagine, the smaller the error term, the better the explanation power of the formula. Yes, the more variables you add to the formula, the smaller the error. But a formula with 2,000 variables equals useless. Maybe a simple example would help. Let's say we own a gas station and want to know what affects our sales, X. We might put a bunch of data into a regression formula including the weather, A, the day of the week, B, and the difference between our posted gas price and competitors' price, C, to see which factors had the greatest influence on sales. 5. Use analytics to ask better questions. Thomas Redman, the data doc, said, "The goal is not to figure out what is going on with the data, it is to figure out what is going on in the world." Boom. Deep. As a managers, we need to think of regression analysis or any analytical tool as a means to ask better questions and get more confident in our thinking. How do you go about choosing relevant variables? Which variables matter most? Which ones can we ignore? How do these variables interact with one another? 6. Recall, correlation is not causality. Correct. Black umbrellas do not cause rain. 7. Recall, life is not a straight line. As seasoned consultants, we know that trend lines are rarely straight lines. Market share gets saturated. Demand elasticity of price changes. The slope, remember rise/run, changes over time. Whether it is customer lifetime value, mortgage amortization, or unit profitability, this varies. Without even labeling the X or Y axis, you can probably think of business situations where you see these scenarios. 8. Get good enough data. Okay, what's good enough look like? In a perfect world, the data you seek would be abundant, easy to get, cheap, unbiased, structured, and almost self-explanatory. It's like being a chef with an infinite pantry of fresh ingredients. Since we know that is unrealistic, we need to evaluate trade-offs. Any publicly available data or already validated data sets that can be repurposed. Can we start with structured data sets, clean, check, and work with first? Do we have a large and representative enough sample size to be valid? Do we know the source and definition of the data sets? Can we set up experiments to test the data validity? 9. No, really, cleanse your data. Nothing is worse than analyzing, visualizing bad data. It's like cooking with rotten ingredients. It's inedible. Look for missing values, convert text to number, clean up typos, e.g., Walmart, 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 Wall asterisk Mart. Identify outliers and determine relevance and how to arbitrate. Create a sample set you can trust, then use it to stress test the larger, unclean data. Crosswalk the data carefully, VLOOKUP, concatenate, keeping an audit trail of your edits. Document the data definitions and get buy-in from stakeholders you will present analyses to. 10. Stay involved in the experiment design. As the business owner, working with an analytics team, you'll be super involved in the beginning and the end of the process. It's up to you to help define the key questions and hypotheses you are testing. Yes, you need to trust the analytics team, but also, yes, verify as you go. Make sure that you are studying a treatment group that looks, feels, sounds like your target. It's easy to go for the cheapest, easiest common denominators, read free online surveys, but let's agree that will skew young, digital, and bored. Randomize people into the treatment and control groups. Yes, you should pick them. Don't let them self-select, I want to be in the financially literate group, please. Be your own best advocate. Wait long enough to get a good sample size. Limit the metrics to something reasonable and please, 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 retest. If you are working on a problem that's big enough to bother, retest. 11. Don't be subtle with the experiments. One of the more provocative points from the HBR guide was the advice that you should use a big hammer when piloting experiments. As counterintuitive as this seems at first, this go big or go home war cry makes sense. There is a lot of noise, and it's too easy for weak signals to get lost. You are testing a hypothesis and can always follow up with more nuanced, particular experiments. The eventual implementation will likely get watered down, so start out with an 80-proof intervention. 12. A/B test. Just like it sounds, A/B testing is the most basic kind of randomized experiment. It's an old idea. Give the same things to two sets of people with only one thing changed. Then see if that makes a meaningful difference. Of course, The online-first companies, e.g., GOG, FB, ABMB, can spin up hundreds of different A/B micro-experiments on you without you ever noticing. Need convincing? Watch Social Dilemma documentary on Netflix. Of course, it's more sophisticated now. Firms can multivariate test A, B/C/D combinations, craftily test different combination subsets, think, conjoint analysis, and infer the rest. Whatever lift they can get between the control and test group is awesome and probably pays for itself. 13. Shoot for a low p-value. With any experiment, you are testing a sample of a larger population. So the size of the sample and underlying variation within that population matters. This is where p-value comes in. A low p-value equals more confidence that the results are not purely by chance. Apparently, statistically significance varies by context. In other words, a scientific academic article might look for a p-value less than 0.05, but in business a p-value as high as 0.2 might be acceptable, useful, and profitable. Thinking of it this way. $impact X high p-value, less significant. Still go for it. $impact X low p-value, highly significant. Perhaps not worth it. 14. Tell a story with the data. As consultants, we know that the data will not explain itself. It's up to us to understand the business context, logically structure the choices, and give our executive clients the courage to act. As Chris Anderson, Wired Magazine, explained, sometimes it's impossible or unnecessary to show causality. Pete Bites allow us to say, correlation is enough. 15. Prevent the yo-yo. It's pretty common to see backsliding when the project ends and no one is watching. Read Anti-Hawthorne Effect. Just like your weight yo-yos after ending the diet, it's too easy to fall into old, bad habits. So what can we do to hardwire the changes by implementing automated metrics tracking and better data practices? Just like they taught you in school, leave the place better than you found it. 16. Find great data scientists. This was a fun way for HBR to end. They listed several ways to find and recruit data scientists. Skin membership roles of user groups are Python. Hang out with data scientists at Strata, Structure, Data, Hadoop World. Make friends with local venture capitalists who've gotten lots of proposals. Host a competition on Kaggle or Topcoder. Don't bother with candidates how can't do some code. Make sure a candidate can find a story in a data set. Be wary of candidates who are too detached from the business world. Ask candidates how they are keeping their skills sharp. See if they've contributed to an open source project or contributed to GitHub. The topic includes both a summary of the work we have accomplished and an invitation for continued professional development in data analytics, data science, machine learning, and artificial intelligence. The topic began with a book review of a popular data analytics for managers textbook published by Harvard Business Review that would be a great resource for your continued professional development. Next, we presented a data analytics/data science short course, which is a great review of some topics we have covered in the course and a look at emerging tools and technologies for data analytics, including R and Python and other database and data science topics.